February 1921, Sakai City, Osaka, Japan. Shoza Buro. Shimano rented a 40 square meter room on the site of a demolished celluloid factory. His monthly rent was 5 yen. His only machine was a single lathe, 1.8 meters long, borrowed from a friend. He was 26 years old. In 2024, the company that Lathe built recorded $2.87 billion in revenue. Fishing tackle alone represented 23.3% of total sales. That fishing business did not exist. When Shimano was founded, it had to be built, and before it could be built, Shimano had to conquer an entirely different market first. Sakai was not a random choice. The city was a legendary blacksmithing centre, historically known for its swords and gun barrels. Metalwork was not an industry in Sakai. It was a culture. Shozaburo had apprenticed at an ironworks after finishing school, rather than follow his father into farming. He arrived at his 40 square metre workshop with trained hands and one clear goal. In his second year, he made his first freewheel. He chose the freewheel because its production was particularly challenging, even in Sakai, and because product quality needed radical improvements. Freewheels made in Japan at that time were far inferior to imports in terms of strength, accuracy, and appearance. Many of the freewheels on Japanese bicycles were foreign-made. Shozaburo fixed that. By 1930, Shimano was producing 30,000 single-speed freewheels per year. To establish a reputation for quality, he offered 2 free replacements for every product that failed. The policy worked. Shimano refused to produce complete bicycles. As one of Shozaburo's sons later said, "Our founder said, never ever compete with a customer. Shimano would make the parts. Someone else would build the bike." That rule held for a century, and it is exactly why Shimano eventually made fishing reels. In 1957, Shimano's engineers attended a trade fair. A West German company was demonstrating cold forging, a technique that shaped a metal using compressive force at room temperature, without cutting or removing material. The Shimano engineers watched, and then they went back to Sakai and spent 5 years figuring out how to do it themselves. Shimano applied cold forging in actual production starting in 1962, making it one of the pioneers of the technique in Japan. The process cuts alloy blocks into blanks, then stamps them into their final shape under enormous pressure. The largest machines Shimano built produce up to 2,000 tons of force. The result was a part that was simultaneously lighter, stronger, and more precise than anything produced through conventional machining. Every bicycle component Shimano made from that point forward was built on that foundation. So was every fishing reel that came after. By the early 1960s, Shimano was ready to take the next step. In 1961, Shimano displayed a 3-speed bicycle hub at the New York Toy Show. The popularity of 20-inch wheeled bikes with high-rise handlebars had created demand for multi-speed hubs, and Shimano was producing an affordable and reliable version that caught the attention of the American industry. The timing was not accidental. Shimano had been watching the American bicycle market closely, and what it saw was an opening. By 1965, Shimano opened its first overseas sales office in New York City. The main purpose was to get quicker product feedback and to provide technical and warranty assistance to retailers selling bikes equipped with Shimano parts. The first office was staffed by 3 people. 3 people. That was the entire American operation. Shimano American Corporation was formally set up in January 1965. It was a bicycle parts distributor. Fishing was not part of the plan yet, but the infrastructure Shimano built in those years, the distribution relationships, the retailer contacts, and the product feedback loops became the exact same infrastructure it would later use to sell fishing reels to American anglers. The American bicycle market rewarded Shimano's investment quickly. When the 1970s United States bike boom exceeded the capacity of European bicycle component manufacturers, Japanese manufacturers, including Shimano, rapidly stepped in to fill the void. In the 1980s, with Shimano pushing technical innovation and lower prices, the more traditional European component manufacturers lost significant market presence. Shimano did not win by being cheaper, it won by being better and cheaper at the same time, which is a combination that established manufacturers almost never see coming until it is too late. In 1970, Shimano made a decision that had nothing to do with bicycles. Shimano launched into the fishing tackle business. The decision was made because fishing would contribute to people's health and continue to be enjoyed into the future, and because Shimano's existing manufacturing technologies could be directly applied. The logic was straightforward. A fishing reel is a precision gear mechanism inside a metal housing. Shimano had been making precision gear mechanisms inside metal housings for nearly 50 years. The product category was different. The manufacturing problem was almost identical. The fishing tackle division was launched as a second business pillar, aligned with the corporate vision of contributing to public health by encouraging outdoor activities. Fishing tackle was added to Shimano American Corporation's product offerings in 1970. From the first day the division existed, the American market was already in the plan. In 1971, Shimano released the Duck spinning reel by harnessing technologies refined in the manufacture of bicycle components, such as gears and body structures. The Ducks was not aimed at American anglers, it was aimed at Japan. Shimano needed to learn how to make reels before it could compete in the most demanding fishing market in the world. In 1972, Shimano released the Ducks Auto. It featured an automatic shifting mechanism whose gear ratio changed automatically depending on the load during winding. It attracted considerable attention for its stainless steel bearings and compact size. Shimano was learning fast, but learning in Japan was not enough. To compete in America, Shimano needed to understand American anglers specifically, what they fished for, how they fished, and what made them buy one reel over another. The answer came through a man named Lou Childre. Lou Childre was a South Alabama entrepreneur. In 1973, he introduced the speed spool bait casting reel to the American market. The reel was manufactured in its earliest years by Shimano. Childre's original interest in Japan, grown bamboo for his fishing rods, had taken him to Japan, where he ultimately teamed with Shimano. The speed spool was unlike anything American bass fishermen had used before. Lou Childre and his speed spool are credited with introducing the low-profile baitcast reel shape, a smooth palming side cover with no knobs for user comfort, and the disengaging level wind. These were not incremental improvements. They were a complete rethinking of what a bait casting reel could be. American bass anglers responded immediately. The speed spool sold, and while it sold, Shimano watched everything, which features anglers praised, which they complained about, how the reel held up in the field, and what they wished it could do that it could not. Shimano was not just a manufacturer on this project, it was a student. The partnership did not last. Childre did not live to see his Lou's products skyrocket in popularity during the bass craze of the late 1970s and into the 1980s. He died in 1977 when a plane he was piloting crashed, and that event led Shimano to enter the American market with its own line of reels. In effect, Childre's death marked the beginning of the ascension of Japanese fishing tackle companies. Childre's death ended the manufacturing relationship, but it did not end what Shimano had learned. Every insight gathered during those years, building the speed spool, went directly into the reel Shimano was already developing on its own. Shimano dispatched engineers to the United States to conduct a field survey for approximately 1 year. The survey found that users needed a more lightweight, compact, and precise reel. Shimano thoroughly reviewed the structure of its prior products, seeking a simpler but stronger design. The development concept focused on user-friendliness, joy, and presence. 1 year, Shimano sent engineers to America not to sell anything, but to listen. They watched bass fishermen cast. They asked what frustrated them about existing reels. They measured what mattered, and they came back to Sakai with a precise set of requirements. Then they built the Bantam 100. In 1978, Shimano launched the Bantam 100 at the American Fishing Tackle Manufacturers Association show, known today as ICAST. The reel was released for sale later that year, with delivery in early 1979. The Bantam 100 could handle 6-pound line, something no comparable reel of that size had previously achieved. It quickly became the lightest reel on the market. Those two facts mattered enormously to bass fishermen in the western United States, where light line fishing was standard practice. A lighter reel reduced fatigue over a full day of casting. A reel that could handle 6-pound line without the line slipping behind the spool opened up techniques that heavier reels made impossible. Shimano focused its advertising on the reel as small and light, yet capable of catching the biggest fish from the nastiest cover. They ran a series of ads showing anglers battling sharks, tarpon, and other saltwater fish. The campaign worked, and Bantam 100s were soon selling all over the nation. The advertising strategy was deliberate. Shimano knew that American anglers, particularly bass fishermen, were aspirational buyers who wanted gear that could handle anything. Showing a compact, lightweight reel fighting a shark in open water told that story without a single word of explanation. The impact on the industry was immediate. It was rumoured that fishing tackle manufacturers around the world were copying the Bantam design. Shimano's reputation in the bait casting reel market was boosted, and for export, Shimano changed its mode of shipment from sea freight to air freight to meet demand. That detail is easy to overlook. It means demand was so high and moving so fast that waiting weeks for a ship was no longer acceptable. Shimano was air freighting fishing reels across the Pacific to keep American tackle shops stocked. The Bantam 100 did not just sell well, it proved something. It proved that American anglers would choose a Japanese reel over an American or European one if the Japanese reel was better. It also proved that Shimano, a company that had spent its entire existence making bicycle parts, could walk into the most competitive fishing tackle market in the world and win on its first serious attempt. The Bantam was just the beginning. The Bantam 100 opened the door. What Shimano built next kept it open permanently. To understand why Shimano's fishing reels became the global standard, it helps to understand exactly what they are made of and how they are made. The answer starts not in a fishing tackle factory, but on a bicycle component production line in Sakai City. Cold forging shapes metal using compressive force, transforming the original material into a near final shape. The technique achieves high rigidity while reducing overall weight, making it ideal for producing strong and lightweight parts for both bicycles and fishing tackle. Cold forging is the key. Every gear inside a Shimano reel is produced this way. The Hagane gear is produced by applying approximately 200 tons of pressure to raw metal. The technology involves no cutting work. It forges a high-precision gear with micron-level accuracy in a single process. The gear teeth are ultra-refined, enabling seamless engagement and power transmission, reducing noise while improving the sensitivity felt in the angler's hand. Hagane matters. Micron-level accuracy means the tolerance, the allowable difference between the design size and the actual size, is smaller than a single human hair. In a fishing reel, that level of precision translates directly into what anglers describe as smoothness. When a Shimano reel feels different from a competitor's reel, that difference is not marketing, it is geometry. Precision cold forging preserves the metal flows of the metallographic structure, the gear with its metal structure intact. Along the processed shape is highly resistant to impact. The surfaces of a Hagane gear have virtually no irregularities. Even after repeated use over multiple fishing seasons, The gear generates minimal noise and continues to reel smoothly. Precision endures. No American fishing reel manufacturer in the 1970s or the 1980s had developed this level of gear production. They were making good reels. Shimano was solving the manufacturing problem at a level the competition had not reached yet. Shimano had an engineering advantage. By the late 1970s, Shimano was not just selling reels in America, it was building the infrastructure to stay. The Bantam series was introduced in 1978, followed by X-Line rods in 1981. Annual sales exceeded 50 billion yen in the mid-1980s. Annual sales reached new heights. 50 billion yen. In the mid-1980s, that translated to roughly $250 million. Shimano was no longer a curiosity in the American fishing market. It was a major commercial force. The product line expanded systematically. The first American market, Shimano spinning reel, arrived in 1983. It was called the BBX reel. It was a plastic-bodied, lightweight freshwater fishing reel. BBX opened a different market. The BBX was aimed at a different angler than the Bantam 100. The Bantam targeted experienced bass fishermen who wanted the best bait casting reel on the market. The BBX targeted the broader freshwater market, the angler who fished lakes and rivers for trout, bass and walleye with a spinning rod. Shimano was not chasing one customer. It was building a product ladder that covered every type of American freshwater fishing. In 1984, Shimano created the Shimano Japan Cup. It was a fishing competition designed to promote the enjoyment of fishing. That same year, Shimano expanded into Canada. Japan Cup became part of the strategy. The Japan Cup was a deliberate cultural move. Shimano understood that fishing tackle is not a purely rational purchase. Anglers are passionate. They follow tournaments. They watch what the best fishermen use and then buy the same gear. By creating and sponsoring competitions, Shimano embedded its brand into the culture of fishing, not just into tackle shops. In 1988, Shimano set up a UK subsidiary focused on fishing tackle sales. That same year, Shimano shifted some of its fishing reel production to Singapore. Moving production to Singapore was a cost and logistics decision. The rise of the Japanese yen in the late 1980s made manufacturing in Japan increasingly expensive for export markets. Singapore offered lower production costs without sacrificing the quality controls Shimano required. The reels that reached American tackle shops were still Shimano reels. They were simply assembled on a different side of the world. Meanwhile, the materials science inside Shimano's reels was accelerating. By the mid-1980s, Shimano recognized the need for stiffer and lighter reel construction. In 1985, the Titano series arrived. It used a composite construction combining titanium fiber, carbon fiber, and resin materials. Titanium fiber, carbon fiber, resin. In 1985, those materials were associated with aerospace and Formula One racing. Shimano was putting them into fishing reels. The Titano series was aimed at the Japanese market first, but the technology it demonstrated, that a fishing reel body could be built from advanced composite materials, set the direction for everything that followed. Then came the Stella. Shimano developed the SBL, the Shimano Balance Lock, to significantly reduce handle shake during rotation. Such shaking had been accepted as the norm for a spinning reel. Since its sensational debut in 1992, the Stella has enjoyed overwhelming support from users around the world. The amazingly smooth reeling feel could be experienced the moment an angler picked it up. Handle shake had been a known problem with spinning reels for decades. Every manufacturer lived with it. Shimano decided to solve it. The SBL system counterbalanced the rotating rotor so precisely that the vibration anglers had always attributed to the nature of spinning reels simply disappeared. To eliminate rotation noise, Shimano used a metal housing with high rigidity and precision. The manufacture of those housings was outsourced to a camera parts manufacturer to attain precision equivalent to that of precision electronic devices. These efforts led to the release of the Stella in 1992, a camera parts manufacturer. Shimano went outside the fishing industry entirely to find a factory capable of machining metal to the tolerances the Stella required. That decision tells the entire story of how Shimano approached product development. If no fishing tackle supplier could meet the specification, Shimano found someone who could. The first Stella model was exhibited at the Tokyo International Fishing Show. The product was suspended using a single line and attracted great attention. The reel was free from shaking during handle rotation and offered a light and smooth feel that visitors had never experienced in a spinning reel before. The 1995 model was equipped with the SHIP system, smooth and high power, which dramatically increased gear reeling performance. Each successive generation did not simply refine the previous model. It introduced a new technology that made the previous generation feel outdated. The Stella SWC, the current top-of-the-line saltwater Stella, retails between $950 and $1,350. A fishing reel that costs $1,350. That price is not an accident, and it is not simply a luxury markup. It reflects the cost of the manufacturing tolerances, the materials, and the engineering that goes into each unit. It also reflects what serious anglers, guides, charter captains, and tournament competitors are willing to pay when they need equipment that will not fail them. By 2012, Shimano introduced the micromodule gear system. It featured precisely shaped gear teeth designed to deliver smooth reeling and excellent power transmission. The micromodule system increased the number of contact points between the drive gear and the pinion gear. More contact points means more even load distribution, which means less wear, less noise, and a smoother feel across the entire retrieve. It was the same logic Shimano had applied to bicycle drivetrains for decades, and it worked in a fishing reel for exactly the same reasons. The scale of what Shimano built across those decades is measurable in precise numbers. In 2024, Shimano recorded total revenue of $2.87 billion. Fishing tackle represented 23.3% of that total. 23.3% of $2.87 billion is approximately $669 million. That is the annual revenue of the fishing division alone, a division that did not exist before 1970, built by a company that had never made a fishing reel before the Ducks in 1971. Shimano maintains a prominent position in the global fishing tackle industry, particularly as a leading brand in spinning reels, competing closely with Daiwa and Abu Garcia. Together, these top three companies command over 55% of global market share. North America's fishing reels market dominated the global market with a revenue share of 60.3% in 2024. The United States held the largest revenue share within that region. The United States is the single largest fishing reel market in the world. Shimano, a company founded in Japan to make bicycle parts, is one of the dominant forces in that market. The resolution is not complicated. In the first quarter of 2026, Shimano's fishing division reported an 18.5% increase in sales compared to the prior year. The company cited firm interest in fishing tackle, appropriate inventory levels, and robust demand for high-priced products, particularly in China and Europe. Shimano started with one borrowed lathe, one product, and a 40 square meter room. It conquered the American bicycle market before most American cyclists knew the brand existed. It entered fishing with no history in the sport and turned a one-year field survey into a reel that air freighted itself across the Pacific because demand outpaced ships. It solved the problems that every other manufacturer had accepted as permanent, and it priced the solution at whatever the engineering required. If you found this story as fascinating as we did, please like the video and subscribe. It helps us tell more stories like this one. In 1955, Tokyo is still rebuilding from the war. Steel is scarce. An engineer named Yoshio Matsui opens a small workshop and starts making fishing reels for export. The reels are cheap. Nobody outside Japan knows his name. Today, that company, Daiwa, is one of the world's most influential fishing tackle brands, with operations across Japan, China, Vietnam, and Malaysia. How did a post-war export workshop get there? Japan after the war. In August 1945, Japan surrendered. The war was over, and the country was in ruins. American firebombing had destroyed large portions of Tokyo. Industrial factories that once produced aircraft engines and military equipment were either bombed out or forcibly shut down by the US occupation authorities. Thousands of workers had no jobs. Millions of people had no reliable food supply. The US occupation government, known as GHQ, took direct control of Japan's economy. Their goal was simple: rebuild Japan as a stable, non-military trading nation. They redirected Japanese factories away from weapons and toward consumer goods: sewing machines, bicycles, radios, cameras, anything that could be exported and sold abroad. Japan had one serious advantage: decades of precision manufacturing for military hardware had left the country with a deep pool of skilled engineers and metalworkers. Those skills did not disappear when the war ended. They needed a new target. The man behind Daiwa, Yoshio Matsui, was one of those engineers. Matsui was born in 1906. He was trained in precision metalworking, the same discipline that had built Japan's wartime machinery. He was also an obsessive angler. He fished constantly, and the more he fished, the more he saw a problem. The fishing reels available in Japan in the early 1950s were functional, but barely. They were heavy, prone to jamming, and produced with inconsistent quality. A reel that performed well one day could fail the next. No manufacturer was applying serious engineering discipline to the problem. Matsui believed he could do better. Building the foundation. In 1955, Matsui opened a small workshop in Tokyo. He called it Matsui Manufacturing. The operation was modest: a tight facility, a small team, and a single focus: building spinning reels for export to the American market. America mattered because American anglers were buying. The post-war US economy was booming. Recreational fishing was growing fast. By the mid-1950s, millions of Americans fished regularly, and the tackle industry was struggling to keep up with demand. Matsui saw the gap and moved toward it. 3 years later, in 1958, Matsui formally incorporated the company as Daiwa Precision Works Corporation. In Japanese, the name was written using kanji characters. The kanji for Daiwa is one of the oldest words for Japan itself. The name was chosen deliberately, and the first reel test was already coming. How fishing reels worked before Daiwa. To understand what Daiwa did, you first need to understand what a fishing reel actually is, and what was wrong with the ones that existed before 1965. A fishing reel is a mechanical device attached to a fishing rod. Its job is to hold fishing line, release that line when you cast, and wind it back in when you retrieve. That is the entire function. Simple in concept, brutally difficult to engineer well. In the 1950s, the dominant reel on the global market was the closed-face reel. A closed-face reel is exactly what it sounds like. The fishing line sits inside a closed housing, a sealed cup that covers the front of the reel completely. The line feeds through a small hole in the center of that cup when you cast. The closed-face design had one major problem. Because the line was trapped inside a housing, the amount of line you could store was severely limited. Less line meant shorter casts. Shorter casts meant fewer fish. Anglers who needed distance, tournament competitors, saltwater fishermen, anyone casting into open water, were working against the very tool in their hands. There was a second problem. Because the line was enclosed, you could not see it. If the line twisted, kinked, or tangled inside the housing, you had no way of knowing until you tried to cast, and the whole thing jammed. Fixing the problem meant disassembling the reel on a riverbank with wet hands. It was a frustrating, time-consuming experience that anglers had simply learned to accept. By the early 1950s, the fishing tackle industry had been selling variations of this same basic design for decades. Nobody had seriously challenged it. Daiwa was about to. The problem Matsui saw. By 1958, Matsui Manufacturing had been producing reels for 3 years. The company was selling into the American export market and building a reputation for reliable, consistent quality. But Matsui was not satisfied with reliable. He was chasing something better. Matsui and his engineers spent those early years studying exactly where the closed-face reel failed. The answer kept pointing to the same place: the spool. The spool is the cylindrical component around which the fishing line is wound. In a closed-face reel, the spool sits inside the housing. That housing was the constraint. It limited spool size, it trapped tangles, and it blocked the angler from any direct contact with the line. The solution, in theory, was straightforward. Move the spool outside the housing, put it on the front of the reel, exposed, where the angler could see it, access it, and load as much line onto it as the cast required. In theory. In practice, moving the spool outside the housing created a cascade of new engineering problems. The line now had to travel from an exposed, rotating spool onto the rod and out through the guides smoothly, without friction, without twist, without the line collapsing back onto itself mid-cast. The mechanism that wound the line back onto the spool after a cast had to be redesigned from scratch. Every single component that had been built around the enclosed design needed to be rethought. Matsui's team worked through those problems one by one. The material problem nobody was solving. By the late 1960s, Daiwa's open-face reel had established the company as a serious global player. The US subsidiary opened on September 26, 1966, operating from a small facility in Culver City, California. Sales were growing, the brand was gaining recognition, and Matsui's engineers were already looking at the next problem. The problem was weight. Every fishing reel in the world, including Daiwa's own products, was built from metal. The body, the rotor, the side plates, all metal. Usually aluminum or zinc alloy. Metal is strong. Metal is durable. Metal also has a fixed weight, and that weight does not go away. For an angler casting once or twice, reel weight barely registers. But serious anglers do not cast once or twice. A tournament-based fisherman might cast 200 to 300 times in a single day. A fly angler casting for hours along a river works their wrist and forearm constantly. Over a full day, the weight of a metal reel accumulates into genuine physical fatigue. Tired arms mean less accurate casts. Less accurate casts mean fewer fish. There was a second weight problem that was harder to solve: corrosion. Metal corrodes. In freshwater, corrosion is slow. In saltwater, the environment for some of the most demanding fishing on Earth, corrosion is fast and aggressive. Salt crystals work into every seam and joint of a metal reel. They grind against the gears, they stiffen the drag, they destroy bearings. Saltwater anglers in the 1960s and the 1970s expected to go through reels regularly. It was accepted as the cost of fishing in the ocean. No manufacturer had seriously addressed either problem. The industry had built better and better metal reels, more precisely machined, more carefully assembled, but the fundamental material was always metal. That constraint had been treated as permanent. Daiwa decided to challenge it. Carbon fiber was not a new material in 1979. Engineers had been working with it since the 1960s. Carbon fiber is made by weaving together extremely thin strands of carbon atoms into sheets or tubes. Those sheets are then bonded with resin to create rigid structural components. The result is a material that is significantly lighter than aluminum, roughly 1/3 the weight, while being comparably strong under most load conditions. By the 1970s, carbon fibre had found applications in aerospace and high-performance racing. Fishing rod manufacturers had also begun experimenting with it for rod blanks, the long tapered shafts that make up the rod itself. Carbon fibre rods were lighter and more sensitive than fiberglass, and they quickly became the preferred choice for serious anglers. But nobody had applied carbon fibre to real construction. A fishing rod is a relatively simple structural component, a tapered tube that flexes under load. A fishing reel is a complex mechanical assembly with spinning parts, gear trains, drag systems, and dozens of individual components that must interface precisely at high rotational speeds. Getting carbon fibre to work in that environment required solving a completely different set of engineering problems. Daiwa solved them. In 1979, Daiwa became the first manufacturer in the world to incorporate carbon graphite into both the reel body and the rotor. The rotor is the spinning arm that wraps line back onto the spool during retrieval, and it is one of the highest stress, highest speed components in the entire reel. Building it from carbon fibre required a precise understanding of how the material behaved under rotational stress and how to engineer the component geometry to take advantage of carbon's strength without exposing its weaknesses. This was an engineering first for the industry. The result was a reel that weighed dramatically less than its metal predecessors, with a construction that was naturally resistant to saltwater corrosion. Anglers who picked it up noticed the difference immediately. The reel felt almost startlingly light compared to anything else on the market, but it was not fragile. Under load, when a large fish was pulling hard against the drag, the carbon body held without flexing. The fishing tackle industry stared at what Daiwa had done and scrambled to respond. Daiwa did not wait for the competition to catch up. Instead, the company declared carbon fibre its primary area of technological focus and began a multi-decade program of refining, improving, and pushing the material further than anyone else in the industry. By the end of the 1970s, Daiwa's global reputation had shifted. The company was no longer just the brand that had built a better spool. It was becoming known by a new phrase that engineers inside and outside Daiwa would repeat for the next 40 years: the carbon specialist. But the carbon work was far from over. In 2007, Daiwa released a material that made everything before it look like a rough draft. Then came MagSealed in 2010. There is a component inside every fishing reel that most anglers never think about until it fails. It is called a ball bearing. A ball bearing is a small metal ring containing a set of tiny steel balls that rotate between two surfaces. Its job is to allow one component to spin relative to another with almost zero friction. In a fishing reel, ball bearings sit at every major rotation point: the main shaft, the handle knob, and the rotor pivot. Without them, the reel would grind itself apart within minutes of use. Ball bearings are precision components. They are manufactured to tolerances measured in fractions of a millimetre. They require consistent, uncontaminated lubrication to function correctly, and they are deeply vulnerable to one specific enemy: water. When water enters a ball bearing, it washes away the lubricating oil that keeps the steel balls spinning freely. Once the oil is gone, the bearing runs dry. A dry bearing running at speed generates heat through friction. That heat accelerates wear. In salt water, the problem compounds rapidly. Salt crystals left behind as the water evaporates grind between the steel balls and their races. They pit the surfaces and make every rotation slightly rougher than the last. An angler fishing in the ocean could feel a reel degrading over the course of a single season. By year 2, bearings that had been silky smooth at purchase were noticeably stiff. By year 3, some were grinding audibly. This was not a Daiwa problem specifically, it was an industry-wide problem. Every manufacturer used metal bearings. Every metal bearing was vulnerable to water. The standard solution was rubber sealing, small rubber rings pressed around the bearing to block water ingress. Rubber seals worked partially. They kept larger volumes of water out, but rubber is a solid material pressing against a rotating surface, which means it creates friction. That friction slows the bearing's rotation and adds resistance to every retrieve. In a high-end reel built for silky smooth performance, rubber seal friction was a meaningful compromise, and rubber seals still allowed microscopic water vapor to pass through over time. In 2010, Daiwa released a solution that the industry had not seen before. They called it mag-sealed. Mag-sealed uses a substance called magnetic fluid, in Daiwa's proprietary formulation referred to as mag-oil. Magnetic fluid is a liquid that contains millions of nanoscale iron particles suspended in a carrier oil. When placed in a magnetic field, those particles align along the field lines. The fluid becomes semi-rigid, and it holds its shape and position as long as the magnetic field is present. Daiwa's engineers placed a ring-shaped magnet around the ball bearing. They then introduced mag-oil into the gap between the magnet and the rotating bearing shaft. The magnetic field held the fluid in place as a continuous liquid ring, a seal with no solid components pressing against the rotating surface. The result was a bearing that was completely isolated from water, without any friction penalty. Mag-oil did not press against the shaft, it floated against it, held in position by magnetism. The bearing could spin at full speed with zero additional resistance, while the fluid ring around it blocked water, dust, and salt particles completely. After Daiwa's testing program put prototype mag-sealed bearings through extreme stress cycles, repeated saltwater immersion, high-speed rotation under load, and sustained pressure testing, the bearings performed identically to their pre-test condition. No degradation, no roughness, no evidence of contamination. Mag-sealed made its public debut in 2010 in the Sertate, one of Daiwa's premium spinning reel lines. Anglers who fished the Sertate in saltwater reported something they had never experienced before, a reel that felt the same in year 3 as it had on the day they bought it. The technology had come directly from aerospace engineering, the same class of material science used to seal rotating components in spacecraft and military hardware. Daiwa had crossed an industrial boundary no fishing tackle manufacturer had crossed before. 3 technologies, 45 years of engineering, the open face reel in 1965, carbon graphite in 1979, mag-sealed in 2010. Each one had solved a problem the rest of the industry had accepted as permanent. But technology alone does not build a global company. For Daiwa to become what it is today, it needed to move beyond Japan. And that expansion started with one small facility in California, why America was the only market that mattered. In 1966, the United States had more recreational anglers than any other country on Earth. Fishing in post-war America had grown from a rural subsistence activity into a mainstream leisure industry. The post-war economic boom had given tens of millions of American families disposable income and free weekends for the first time. They bought boats, they bought gear, they drove to lakes and rivers every weekend in enormous numbers. By the mid-1960s, the United States recreational fishing industry was generating hundreds of millions of dollars in annual revenue, and it was still growing. The American fishing tackle market had a structure that worked in Daiwa's favor. It was fragmented. Dozens of domestic and international brands competed for shelf space in tackle shops and sporting goods stores, but no single manufacturer dominated. The market rewarded performance and price simultaneously. Anglers wanted the best reel they could afford, and they were willing to switch brands if something better appeared at the right price point. Daiwa had spent the first decade of its existence building exactly that, a technically superior product at an accessible price. The open face reel, released in 1965, was the proof. It outperformed what American anglers were used to. It was priced within reach of the average recreational fisherman. And it was coming from a Japanese manufacturer that had no legacy reputation in the American market to protect, which meant Daiwa had nothing to lose by disrupting it. The decision to enter the United States was not cautious. It was direct. Why Europe was a different challenge. Europe presented a different problem than America. In the United States, recreational fishing was largely unified around a handful of dominant styles: bass fishing, trout fishing, and saltwater sport fishing. The tackle preferences that came with those styles were well understood. A manufacturer who built a good spinning reel and a good bait casting reel could address the majority of the American market with a focused product lineup. Europe had no such unity. European fishing culture in the 1970s was deeply regional and intensely traditional. British coarse anglers, fishermen who targeted species like carp, bream and roach in rivers and lakes, fished with techniques and equipment that had developed over centuries. They had strong opinions about gear and strong loyalty to established brands. French anglers fished differently from British anglers. German anglers fished differently from both. Scandinavians fished for different species in different environments with different tackle requirements. To build a serious European business, Daiwa needed to be physically present inside those markets, manufacturing products adapted to local preferences, working with local retailers, and earning trust from communities that did not automatically respect foreign brands. That meant building in Europe, not just selling into it. The two-tier manufacturing strategy. By the mid-2000s, Daiwa had built a global manufacturing structure that no competitor had fully replicated. At the top tier, Japan. The flagship facilities in Higashikurume, Tokyo, where Daiwa's global headquarters and primary R&D operations are based, produce the company's premium reel lines. The Certate, the Exist, the Zillion. These are reels built to the tightest tolerances Daiwa's engineers can achieve, using the most advanced materials in the lineup, assembled by technicians with years of specialized training. Japan-made Daiwa reels carry a different designation on their packaging from reels made elsewhere, and that designation carries meaning in the market. Serious anglers know what it means. It means the reel was built without compromise. At the lower tiers, China, Vietnam and Malaysia produce Daiwa's mid-range and entry-level lines. These are reels built for anglers who want Daiwa quality and engineering but cannot pay flagship prices. The materials are different, less exotic composites, less precisely machined metal, and the assembly processes are adapted to higher production volumes. But the design philosophy behind them comes from the same engineering team in Tokyo, the same drag principles, the same gear geometry, the same fundamental architecture built to a different cost point. This structure solved a problem that had frustrated Daiwa for years. A company that only makes expensive products can only reach expensive customers. The global fishing market has hundreds of millions of participants, and the vast majority of them are not buying flagship reels. They are buying their first reel, or their second reel, or a backup reel for a style of fishing they do occasionally. Those anglers needed a product they could trust at a price they could justify. The offshore manufacturing strategy made that possible. Mid-range and entry-level Daiwa reels produced in China, Vietnam and Malaysia allowed the brand to occupy shelf space in tackle shops at every price point, from $80 to $800. An angler who bought a $90 Daiwa spinning reel as their first purchase and had a good experience with it was a likely candidate to buy a $300 Daiwa reel when they decided to upgrade, and a possible candidate to eventually buy a Japanese-made flagship. The quality control system underpinning both tiers was the same, regardless of which country a reel was assembled in. Every unit went through Daiwa's standard testing and inspection protocols before it left the factory. A reel that failed the performance benchmark was reworked or scrapped. The manufacturing location changed the cost structure. It did not change the standard. By 2018, the company behind Daiwa, now operating as Globeride Inc., after a corporate renaming in 2009, employed 5,848 people on a consolidated basis across all its global operations. Manufacturing facilities operated in Japan, China, Thailand, and Vietnam. The single rod factory in Wishaw, Scotland, continued producing exclusively for the European market. Subsidiary offices operated across the United States, Australia, France, Germany, Italy, Singapore, South Korea, Malaysia, Thailand, and Taiwan. From a small workshop in post-war Tokyo, Daiwa had built a manufacturing and distribution network that spanned every major fishing market on Earth. And through all of it, the geographic expansion, the offshore production, the subsidiary network, the technology coming out of the Japanese headquarters kept advancing. A company that changed its name. In October 1st, 2009, the company that built Daiwa did something that surprised the fishing world. It erased its own name. Daiwa Seiko Corporation, the legal entity that had operated under that name since 1958, officially rebranded itself as Globeride Inc. on October 1st, 2009. The timing was deliberate. That year marked the company's 50th anniversary. Management had decided that after half a century of operation, the corporate structure no longer reflected what the business had actually become. To understand why, it helps to understand what Daiwa Seiko had been quietly building alongside its fishing business for decades. Through the 1970s and the 1980s, the company had diversified into other sports equipment categories. Golf was the largest addition. The logic was straightforward. Golf equipment, like fishing tackle, required precision manufacturing, high-performance materials, and an engineering-first approach to product development. The same factories, the same material science, the same manufacturing disciplines that produced carbon fiber fishing rods could be redirected toward golf club shafts and club heads. The capability transferred. By 2009, the company's portfolio extended well beyond fishing. It included licensed Prince brand tennis gear. It included G3 brand golf equipment. It included Bottecchia bicycles, an Italian cycling brand with a racing heritage dating back to the 1920s. The company was operating across 4 distinct sports categories simultaneously. The name Daiwa Seiko, which translated closely to Daiwa Precision Works, described a fishing tackle manufacturer. It did not describe a multi-sport company with subsidiaries on 5 continents. Globeride did. The new name came from the phrase Globeride. It was designed to signal global ambition and broad engagement with outdoor and recreational sports worldwide. The Daiwa fishing brand was retained in full. Every reel, every rod, every product sold under the fishing division kept the Daiwa name. What changed was the corporate identity of the parent company sitting above it. The numbers confirmed exactly what had not changed. In fiscal year 2019, fishing products accounted for 87.4% of Globeride's total revenue. Golf contributed 5.0%. Racket sports added 6.7%. Cycling and other categories made up the remaining 0.9%. Nearly 9 out of every $10 the company earned came from fishing. The name had changed, the business had not. The rival that made Daiwa better. No story of Daiwa is complete without the company that has competed against it, pushed it, and forced it to improve for more than 5 decades. That company is Shimano. Shimano was founded in February 1921 by Shozaburo Shimano in Sakai City, Osaka Prefecture. Sakai was known historically as a precision manufacturing center, a city with centuries of metalworking tradition built on sword-making and gunsmithing. Shimano's first product was a bicycle freewheel. A freewheel is the ratcheting mechanism on a bicycle wheel that allows the rider to coast without pedaling. It is a small, precise, load-bearing component that must function reliably through thousands of rotation cycles. Building it well required exactly the kind of tight engineering tolerances that Sakai's manufacturing culture had developed over generations. For nearly 50 years, Shimano focused almost entirely on bicycles. The company grew into one of the dominant bicycle component manufacturers in the world, with products appearing on bikes sold across Europe, North America, and Asia. Then, in 1970, Shimano launched a fishing tackle division. At that point, Daiwa had been making fishing reels for 15 years. It had already introduced the open-face spinning reel that had changed the industry. It had a US subsidiary, an Australian operation, and a growing international reputation. Shimano was starting from zero in fishing, a company that knew nothing about reels, with no fishing products, no fishing brand recognition, and no relationships with the tackle trade. But Shimano had something that made it dangerous from the first day it entered fishing. It had 50 years of engineering expertise applied to components that operated under load, at speed, through thousands of repetition cycles. A bicycle gear cassette and a fishing reel gear train are not the same thing, but the engineering discipline required to build one transfers directly to building the other. Shimano understood tight tolerances, it understood material fatigue, it understood what happened to mechanical components when they were used hard, repeatedly, over years. Shimano's first fishing reel, the Duck series, a spinning reel released for the Japanese domestic market in 1971, was not revolutionary. But it was precise, and within a decade Shimano's fishing products had become a serious competitive force in the global market. By the 1980s, the fishing tackle industry had effectively bifurcated into two dominant camps. There were Daiwa anglers and there were Shimano anglers. Both brands produced high-quality products across a wide price range. Both brands invested heavily in proprietary technology. Both brands had global manufacturing and distribution networks, and both brands were watching each other extremely carefully. The competition between Daiwa and Shimano has never been resolved. It is ongoing. Today, the two companies are universally recognized as the top two fishing tackle manufacturers in the world. Ask any serious angler which brand is better, and you will not get a consensus answer, because there is no consensus answer. The honest comparison looks like this. Daiwa leads in lightweight construction and saltwater protection technology. Shimano leads in gear strength and broad product consistency. Neither company has a monopoly on excellence. Both are genuinely world-class. What the rivalry produced beyond decades of argument in tackle shops was acceleration. Every time Shimano released a new gear system, Daiwa's engineers studied it and pushed harder on their own. Every time Daiwa released a new carbon compound or a new sealing technology, Shimano's engineers responded. The pressure was constant and mutual, and the beneficiaries were the anglers who used the products. The fishing reel that a recreational angler picks off a tackle shop shelf today, at almost any price point from either brand, is dramatically more capable, lighter, and more durable than anything available in 1970. That improvement did not happen because either company worked in isolation. It happened because they competed. What Daiwa actually built. Step back from the individual technologies, the global subsidiaries, the corporate restructuring, and the shape of what Daiwa actually accomplished, and the picture becomes clear. In 1955, Yoshio Matsui opened a workshop in Tokyo and started making fishing reels. The country around him was still rebuilding from destruction. The fishing tackle industry worldwide was dominated by established Western and European brands. Japan was not considered a source of precision consumer products. It was considered a source of cheap imitations. Matsui did not accept that definition. Over the following 70 years, the company he built introduced the open-face spinning reel in 1965, a design that displaced the dominant closed-face reel and became the global standard. It became the first manufacturer in the world to put carbon graphite into a reel body and rotor in 1979, a material innovation that permanently changed how reels were built. It released Zion in 2007, a high-density carbon compound that outperformed metal in critical structural categories. It deployed MagSealed in 2010, an aerospace-derived bearing protection system that solved a corrosion problem the entire industry had accepted as permanent. Every one of those innovations came first from Daiwa. Every one of them was subsequently adopted, adapted, or responded to by the rest of the industry. The technologies that define modern fishing reel construction, lightweight carbon bodies, open spool design, and magnetic sealing, were not developed by a committee of established manufacturers protecting their market positions. They were developed by an engineer in post-war Tokyo who believed the existing products were not good enough. By 2018, Globeride Incorporated, the parent company of the Daiwa brand, employed 5,848 people across consolidated global operations. It maintained manufacturing in Japan, China, Thailand, and Vietnam. It operated subsidiaries in the United States, the United Kingdom, Australia, France, Germany, Italy, Singapore, South Korea, Malaysia, Thailand, and Taiwan. Its fishing division alone generated 87.4% of total company revenue. The workshop in Tokyo that Yoshio Matsui opened in 1955 is now one of the two companies that define the global fishing tackle industry. He built that from scratch in a country that had just lost a war, with nothing but engineering discipline and a refusal to accept the limitations of what already existed. That is the story of Daiwa. If you learned something today, subscribe and give this video a like, only if you think it deserved it. In 1887, Henning Hammarlund built Sweden's first pocket watch factory in Svängsta, a small village in the Blekinge region beside the Mörrum River. He named it Halda Fabrik AB. Halda's watches won gold medals at world fairs in Chicago in 1893, Stockholm in 1897, and Paris in 1912. 34 years later, a former Halda employee named Carl August Borgström bought Halda's machines and started his own company on the same riverbank. He called it AB Fabriken. It made watches. Carl August Borgström started AB Fabriken in 1921 with 17,000 kroner. He bought the machines directly from the shuttered Halda factory and moved them into an old chapel building on Hollandarevagen, the same street, the same river, the same village. The name he chose told the whole story. AB stood for August Borgström. Fabriken was Swedish for watch factory. Together, ABU's first products were telephone timers called the teller. One of ABU's first clients for the teller was LM Ericsson, the company that would eventually become one of the largest telecommunications corporations on Earth. In 1926, ABU added taxi meters to its product line, building meters for horse wagons and taxicabs across Sweden. Carl August died in 1934 at the age of 63. His son Gote, then 30 years old, took over the company. Gote was not just a businessman, he was a fisherman. The Mörrum River ran directly outside the factory walls, and Gote had grown up fishing it. By 1939, Gote and his engineer, Stig Svensson, had spent 5 years developing a new taximeter. The record taximeter Model 39 was the lightest and most compact on the market. That same year, Germany invaded Poland. World War II reached Sweden's economy in September 1939. Within weeks, European trade collapsed. Taximeter exports, the product Gote had spent 5 years perfecting, stopped completely. ABU had 18 years of precision manufacturing behind it. The machines were still running. The craftsmen still showed up every morning. The factory on Hollandarevagen had not changed. What had changed was that nobody needed taximeters anymore. Gote Borgström made a decision in 1940. He would not wait for the war to end. ABU would change what it built. He did not choose fishing reels randomly. Gote had fished the Mörrum River his entire life. His father, Carl August, had hand-built a simple reel for fishing that same river years earlier. Gote understood fishing tackle the way a watchmaker understands a movement, by feel, by function, by what was missing. What was missing, in Gote's assessment, was precision. The reels available to Swedish anglers in 1940 were crude compared to what a factory full of watchmakers could produce. Gote bought several of the most popular American bait casting reels on the market and took them apart on his workbench. He studied each one. He noted what worked. He noted what did not. Then he set ABU's craftsmen to work building something better. In 1941, AB Fabriken introduced its first fishing reel. It was called the ABU Record. The record was built to the same tolerances ABU had used for 2 decades to build watch gears and taximeter mechanisms. It was not a hobby product. It was a precision instrument that happened to be designed for fishing. The ABU Record sold. It proved the concept, but Gote was already thinking past it. The problem Gote was turning over in his mind was casting. Specifically, the problem every angler in the world faced in 1941 when using a bait casting reel: backlash. When a bait casting reel's spool spun faster than the line leaving it, the line piled up and tangled into what anglers called a bird's nest. Clearing a bird's nest could take 10 minutes. It happened to beginners constantly and to experienced anglers regularly. Every reel manufacturer in the world had accepted it as an unavoidable feature of bait casting. Gote did not accept it, did not. In 1949, Gote Borgström hired an engineer named Ake Mervall. Mervall's title was production manager and construction manager. His real function was to solve problems that no one else had solved. Merville was not a fisherman. That was deliberate. Gautier needed someone who would approach the reel as an engineering problem, not as a fishing tradition. Gautier provided the fishing knowledge, every cast, every tangle, every frustration he had accumulated over decades on the Morum. Merville provided the mechanical solutions. Together, they began work on a reel that had never existed before. Together, they would rebuild how casting worked. Between 1949 and 1951, Gautier and Merville worked through the core engineering challenge. A bait casting reel's spool needed to spin freely during a cast to achieve distance, but a freely spinning spool with no governing mechanism would always outrun the line. The solution Merville engineered was a centrifugal brake, a set of small brake blocks inside the spool that used centrifugal force to automatically slow the spool as it accelerated, preventing it from spinning faster than the outgoing line. No production reel in the world had combined a centrifugal brake with a free-running spool and a level wind mechanism in a single unit. A level wind mechanism was a guide that moved back and forth across the spool automatically during retrieval, laying the line evenly so it would cast cleanly on the next throw. Level wind. The combination of all three systems in one compact, anodized aluminum body was the engineering breakthrough. By May 1951, the first physical test reels existed. 5 were produced that month, 1 in each of 5 colors. The first prototypes. By October and November of the same year, 60 more prototype reels had been built, 20 in red, 20 in green, and 20 in black. The color decision was not cosmetic. Every other reel on the market in 1951 was either nickel-plated or chrome-plated. Both finishes were silver. The new reel was made from anodized aluminum, which meant for the first time in the history of fishing reels, color was a manufacturing option. Gautier understood this was a marketing opportunity unlike anything the industry had seen. In August 1952, Gautier took the finished reel to Stockholm. The venue was the St. Erik's Fair, one of Sweden's largest consumer exhibitions. Visitors to the ABU stand were shown 3 versions of the reel, red, black, and green. They were asked to vote for their preferred color. Black won the vote. Gautier had already decided on red. He had fallen in love with it during the prototype phase. No other bait casting reel in the world was red. Every reel on the market was silver. A red reel on a Swedish salmon river would be impossible to miss and impossible to forget. Red went into production. A magazine advertisement placed in late 1952 carried the headline, "Technical Perfection, the Ambassador from Svankstad." The reel was priced at 150 krona, a significant sum at the time, equivalent to roughly several days of wages for a Swedish factory worker. It was ready for delivery by Christmas 1952. It first appeared in the Tight Lines fishing catalogue in 1953 under the full name, the Record Ambassador. The Record Ambassador was the world's first fishing reel to combine 3 technologies in a single unit: a free-running spool, a level wind mechanism, and a centrifugal brake. The anodized aluminum body was lighter than any chrome or nickel-plated reel on the market. The push-button free spool release allowed an angler to disengage the spool with a single thumb press before a cast, then re-engage it automatically on the first turn of the handle. These were not incremental improvements. They were new features that the fishing world had not had before. Gautier had built a reel that made the act of casting easier, more accurate, and more consistent for every angler who held one, from the most experienced salmon fisherman on the Morum to someone picking up a rod for the first time. By 1954, the reel was selling in Sweden, but Gautier knew the real market was elsewhere. In 1954, Gautier's son, Lennart Borgström, joined ABU as export manager. He was 24 years old. His job was to take the Ambassador to the world. That same year, Gautier and Lennart traveled to the United States for the first time. Their destination was Chicago. They stayed at the Conrad Hilton Hotel, where the American Fishing Tackle Manufacturers Association, known as AFTMA, held its annual trade show. The AFTMA show was the single most important gathering in the American fishing tackle industry. Every major buyer, distributor, and retailer in the country attended. Gautier did not speak English, not a word. Lennart handled every conversation. He stood at the ABU display and explained the ambassador's features to American buyers: the centrifugal brake, the level wind, the push-button-free spool, the anodized aluminum body, and the red finish that no other reel in the room shared. Gautier stood beside him and demonstrated. He cast the reel, he let buyers hold it. He smiled, and he let the reel speak in the language he did not have. At that show, the Ambassadeur 5000 cost $45. In 1954, $45 represented roughly a week's wages for an average American worker. It was not a cheap reel. The buyers did not care. The reel cast further, more accurately, and with fewer tangles than anything else on the table. The Americans loved it. One buyer at that show was a representative from a New Jersey-based fishing tackle distributor called the Garcia Corporation, formerly known as Charles Garcia and Company of New York City. Garcia was the largest sporting goods distributor in the United States. A deal was not struck immediately. Garcia's leadership initially showed limited interest. That would not last long. By 1956, Garcia had recognized what it had passed on at the AFTMA show. A new agreement was reached. Garcia became the exclusive ABU distributor for the entire United States market. Garcia catalogued the Ambassadeur for the first time in its 1957 trade catalogue. A small factory beside a river in a Swedish village of several hundred people was now supplying the biggest fishing tackle distributor in America. The Ambassadeur 5000 was about to reach every tackle shop, every sporting goods store, and every serious angler in the United States. By 1956, the Ambassadeur was selling across the United States through Garcia's distribution network. ABU's factory on Hollanderavagen was running at a pace Carl August Borgström could not have imagined when he moved his watchmaking machines into that old chapel in 1921. But Gautier Borgström was not finished building. In 1955, ABU introduced its first spinning reel. It was called the ABU 444. A spinning reel operates differently from a bait casting reel. The spool stays fixed during a cast, and the line peels off the front of the spool, rather than unwinding from a rotating drum. The ABU 44 gave ABU a product for anglers who preferred spinning over bait casting, which was a significant portion of the global market. In 1956, ABU introduced the ABU-matic. The ABU-matic was a spin-cast reel, a design that enclosed the spool inside a cone-shaped cover with a single push-button release. Spin-cast reels were simpler to operate than either bait casters or spinning reels, which made them popular with beginners and casual anglers. ABU built its version with the same precision tolerances it applied to every product that left the Svanksta factory. The ABU-matic also became the subject of one of the most deliberate traps in the history of industrial manufacturing. By the late 1950s, ABU's products were being copied. Manufacturers in other countries, most notably Japan, were producing near-identical versions of ABU reels and selling them at lower prices. ABU's legal team needed a way to prove copying in court, but proving that a competitor had copied a design required evidence that went beyond visual similarity. Ake Mervel's engineering team provided that evidence in advance. During the development of the ABU-matic, a small hole had been drilled into the prototype housing to secure the spool during testing. When the final production design was completed, the spool was secured by a different method. The hole was no longer needed. It served no mechanical function on the finished reel. Mervel left the hole in. When Japanese copies of the ABU-matic appeared on the market, they included the hole. A hole with no mechanical purpose, present in both the original and the copy, was proof in court that the design had been directly duplicated. ABU used that evidence successfully. The non-functional whole had done exactly what Merville intended it to do. In 1963, the first Japanese copies of the Ambassadeur itself appeared. By that point, the Ambassadeur had been on the market for 11 years. It had been copied because it was worth copying. In 1965, ABU introduced the Cardinal spinning reel series. The Cardinal became one of the most celebrated spinning reels ever produced. In the early 1970s, dedicated carp anglers across Europe, including some of the sport's most prominent figures, adopted the Cardinal 55 as their reel of choice, citing its drag system and overall build quality as unmatched at the time. At some point during ABU's years of growth, the company received recognition that no distributor agreement or trade show appearance could provide. ABU was awarded a Swedish royal warrant. The formal title was Kunglig Hovleverantor, purveyors to the court of Sweden. The warrant was granted by the Swedish royal family in recognition of the company's quality and craftsmanship. It entitled ABU to display the royal seal on its products. A factory that had started by making telephone timers and taximeters was now the official fishing tackle supplier to the Swedish crown. In May 1974, Göte Borgström died. He had taken a failing taximeter company in the middle of a world war and turned it into the most respected fishing reel manufacturer on Earth. The Ambassadeur had been in production for 22 years at the time of his death. It was being sold on every continent where people fished. His son Lennart Borgström, who had stood beside him at the Conrad Hilton Hotel in Chicago in 1954 and translated his father's demonstrations into English, now carried the company forward. The Ambassadeur kept selling. New models followed the original. The 5000 series expanded. The 6000 series was introduced. Each new model retained the core engineering that Göte and Ake Merville had developed in Svanksta: the centrifugal brake, the level wind, the free-running spool, the anodized aluminum body. By 1980, the relationship between ABU and the Garcia Corporation had deepened beyond a distribution agreement. Garcia had been ABU's exclusive American distributor since 1956. In 1980, ABU Svanksta acquired the New Jersey-based Garcia Tackle Company outright. The two names that had been linked since the 1950s were now a single company. In 1984, the name became official. The company was formally renamed Abu Garcia, the brand name that anglers around the world now recognize on every reel, every rod, and every piece of tackle, was the product of that 1984 renaming, itself the product of a 1980 acquisition, itself the product of a distribution deal struck in 1956 at a trade show in Chicago, itself the product of a red reel built by a watchmaker's son in a village beside a Swedish river. By the mid-1980s, the factory on Holland Arevagen in Svanksta had produced millions of reels. The exact cumulative total, counted across the full history of the factory, would eventually reach 33 million. But the business was changing around Abu Garcia in ways that the Borgström family had not faced before. Through the late 1980s and into the early 1990s, Abu Garcia faced compounding financial pressure. The Swedish tax system placed heavy burdens on manufacturing companies. Global competition from Asian reel manufacturers, the same manufacturers ABU had been fighting in court since the 1960s, had matured into legitimate competition, producing quality products at significantly lower cost. Abu Garcia was losing ground commercially, even as its reputation remained intact. By the mid-1990s, the options had narrowed to two. Abu Garcia could cease operations entirely, ending 74 years of continuous manufacturing on Holland Arevagen. Or it could accept acquisition by a larger corporation that had the capital to sustain it. In 1995, Abu Garcia became part of the Outdoor Technologies Group. In 2000, Outdoor Technologies Group changed its name to Pure Fishing. Under Pure Fishing, Abu Garcia was placed alongside a portfolio of brands that grew to include Berkeley, Penn, Shakespeare, Pfluger, Mitchell, and Fenwick. Pure Fishing became one of the largest fishing tackle conglomerates in the world. In April 2007, the Jarden Corporation acquired Pure Fishing. In December 2015, Newell Rubbermaid acquired Jarden Corporation. In November 2018, Newell Rubbermaid sold Pure Fishing to Sycamore Partners, a private equity firm based in New York City. Abu Garcia had passed through 4 different ownership structures in 23 years. Each transaction was larger than the one before it. Each one moved the company's ownership further from Svankster. The factory on Hollander Evergen kept running through every transaction. In 1991, the Svankster factory introduced automated assembly for the Ambassadeur handle side plate. A series of machines now produced the component at a speed and consistency that manual assembly could not match. That automation was the specific reason the Svankster factory could continue operating after Abu Garcia's manufacturing shifted increasingly to Asia. Without it, the cost differential would have made the Swedish factory impossible to justify. Today, most Abu Garcia reels are manufactured in China and Korea. The cost economics of global manufacturing made the shift inevitable. But one reel line has never left Svankster. The Ambassadeur, the reel Gotte Borgström, and A.K. Merville designed between 1949 and 1952 in a converted chapel beside the Morum River, is still built on Hollander Evergen. Collector's editions, custom models, the C3 and C4 series, up to size 6500, all of them still come from the same address. The factory that opened in 1921 has been in continuous operation for over 100 years. When John Wayne was introduced to Lennart Borgström at a marina in Cabo San Lucas, Mexico, he grabbed a chair, sat down next to Lennart, and told him he could not believe it, and that he had to have a dozen of those. He was talking about the Ambassadeur, a Hollywood actor with a converted US Navy minesweeper, as his private vessel owned 12 of them. Lennart Borgström asked about the durability of the Ambassadeur late in his life, said he did not know of anyone who had really worn one out. You cannot wear out an Ambassadeur, you can wear it in. In 2013, Abu Garcia commissioned a documentary about its own history. The film was called For Life, the story of Abu Garcia. It was shot across 14 locations, from Sweden to the United States, and featured perspectives from 13 individuals. The Swedish phrase in the film's original title was Allting går igen, which translates to everything comes round. The factory on Hollander still stands. The Morum River still runs beside it. Over 33 million reels have been made inside that building, the same building where Carl August Borgström set up his watchmaking machines in 1921, in a village that cost 800 kroner to build a factory in. Beside a river, his grandson would spend a lifetime fishing. If this story earned your time, subscribe and give this video a like. It helps more people find stories like this one. In 1832, a farmer built a nail factory in Vardal, Norway. The government said it would fail. Officials declared that competing with foreign factories was impossible, and the industry would never succeed in Norway. 179 years later, that same company made one in every 4 fish hooks on Earth. In dozens of languages, the word mustad had become the word for fish hook. How did a nail shop in rural Norway get there? Ola Hovelson Mustad takes over. That same year, his son-in-law stepped in. Ola Hovelson Mustad was born in 1810. He had married Skikkelstad's daughter, Anna Marie. When Skikkelstad died, Ola inherited the factory and renamed it O Mustad. Ola expanded the factory into a foundry and added a sawmill. By 1860, the company held a leading position in Norway for the production of fencing wire, nails, pins, fish hooks, horseshoe nails, shipbuilding nails, paper clips, and thumbtacks. Hans Mustad joins in 1874. Ole's son Hans Mustad became co-owner. Hans was born in Vardal in 1837. Under Hans, the company diversified further. Horseshoes, axe heads, and fish hooks were added to the production line. The name was updated to O Mustad and Son. That same year, Hans bought property at Lilleaker, a district in Christiania, the city now called Oslo. In 1876, nail production moved from Vardal to Lilleaker. The factory at Vardal was freed up. Hans directed it toward fish hooks, a company that made everything. At this stage, Mustad made dozens of products: ovens, waffle presses, butter. The company competed in Norway's butter industry for over 100 years. Fish hooks were one line item among many, but something was happening inside the Vardal factory. Matthias Topp. In 1862, a factory carpenter named Matthias Topp was promoted to foreman. He had a side project. Every fish hook in the world was made by hand. A worker cut a length of steel wire, bent it, barbed it, and sharpened it, one hook at a time. The process was slow and expensive. Fishing was not a hobby in the 1860s. It was how hundreds of millions of people ate. Global demand for hooks was enormous, and no one had found a faster way to make them. Topp believed a machine could. He began drawing designs, building prototypes, and testing them. He failed repeatedly. He rebuilt. After more than a decade of work, in 1877, Topp finished the machine. The problem with making fish hooks in 1862. In 1862, every fish hook in the world was made the same way. A worker took a length of steel wire. He cut it to size. He bent it into a hook shape. He filed a barb into the point. He sharpened the tip. Then he set it aside and picked up another wire and started again. One worker, one hook every time. The process had not changed in centuries. Fishing was not a sport in the 1860s, it was survival. Coastal communities across Europe, Asia, and the Americas depended on fish as a primary food source. Fishermen needed hooks by the thousands. Commercial fishing boats went to sea, carrying tens of thousands of hooks on a single long line. The demand was continuous, global, and enormous. The supply side could not keep up. Hand-making hooks was slow, labour-intensive, and inconsistent. Every hook that came off a worker's bench was slightly different. Quality varied. Output was limited by how many hours a man could work. The fishing industry needed more hooks, faster, and at a price that working fishermen could actually afford. Nobody had solved this, not in England, where hook manufacturing was the most advanced in the world, not anywhere. That was the problem sitting in front of Matthias Topp in 1862. Matthias Topp begins. Topp was a carpenter. He had been hired at the Mustad factory in Vardal to work with his hands and manage the people doing the same. He was promoted to foreman in 1862. His job was production oversight, but Topp had an engineering mind. He looked at the hook-making process and saw something that most people in the industry had accepted as fixed: the human hand as the only tool. Top did not accept that. He believed a machine could replicate every step a human hand performed: cut, bend, barb, sharpen, in a single continuous motion. He began drawing designs. The problem was extraordinarily difficult. A fishhook is a small object, but it requires precise geometry. The bend has to be exact, the barb has to be positioned correctly, or the hook will lose fish. The point has to be sharp enough to penetrate a fish's mouth on contact. Getting a machine to perform all four operations on a moving length of wire accurately, thousands of times per hour, required an entirely new kind of mechanism. Top tested designs. They failed. He rebuilt them. They failed again. He adjusted tolerances, changed materials, and reworked the wire feeding mechanism. This went on for 15 years. In 1877, the machine worked. What the machine did: the hookmaker took a continuous spool of steel wire as its input. The wire fed into one end of the machine. Out the other end came finished fish hooks, cut, bent, barbed, and pointed in a continuous stream. A single trained worker operating the machine could oversee an output that previously required an entire room of hand workers. The hooks were not just faster to produce, they were more consistent. Every unit that came off the machine was identical to the last. No variance in bend angle, no difference in barb position, no variation in point sharpness. This mattered enormously in the fishing industry. A hook that bent under pressure lost fish. A barb placed incorrectly allowed a fish to shake free. Mustad's machine made hooks performed identically every time. Commercial fishermen who switched to Mustad hooks saw fewer losses. They came back. The fishing industry had its solution. Mustad had its weapon. The decision: no patent. Hans Mustad faced an immediate choice. The machine was an invention. Inventions could be patented. A patent would give Mustad legal protection and public credit. It would also put the machine's design into the public record, available for any competitor to study, improve upon, and eventually replicate once the patent expired. Hans Mustad chose secrecy instead. Workers at the factory were restricted from entering the area of the building where the hookmaker operated. Those who did have access were required to sign non-disclosure agreements, written commitments not to describe or share what they had seen. The blueprints for the machine were encrypted, stored in a form that could not be easily decoded by an outsider. No patent was ever filed. Without a patent in the public record, no competitor could legally reverse engineer the machine. Mustad had an exclusive manufacturing capability that it could hold indefinitely, not for the 17 years a patent would have provided, but for as long as the secret held. The secret held for decades. Henry Haynes and the English expertise. Hans Mustad sent employees to visit hook factories and fishing operations across Europe. He was gathering intelligence on what the best manufacturers in the world knew. The most advanced hook-making knowledge at the time sat in England. English hookmakers had been refining their craft for generations. Henry Haynes was one of those men. Haynes was an English fisherman with expertise in fly tying and in the metallurgical process of tempering, heat-treating steel to give it the right balance of hardness and flexibility. Hans Mustad brought Haynes to Norway. Haynes was the first of several English specialists Mustad recruited over the following years. The goal was self-sufficiency. Hans wanted a company that trained its own workers, developed its own techniques, and passed that knowledge down internally, generation to generation, employee to employee, so that expertise never walked out the door when a worker left. Mustad became the first hook company to fully train its own workforce and develop its own internal marketing strategy. Decades later, employees at the Gjøvik factory could trace their family's connection to the company across multiple generations. What the crisis built. The recovery meant more than financial survival. The crisis had demonstrated something about the relationship between the Mustad family and its workers that a normal business arrangement could not create. After 1882, Mustad expanded its responsibilities to the families of its employees. Children of workers were given access to company-funded schools. Recreational programs were established. A library was built, a band, a choir, a company shop. The factory became the centre of community life in Gjøvik. The press began visiting. Journalists came to see what a Norwegian industrial company looked like when it invested in its own people. They published what they found. The reputation spread. People wanted to work for Mustad. Workers who joined tended to stay. Their children joined after them. Going international. By the mid-1880s, Mustad had reached the limits of the Norwegian market. The company needed to expand, and it ran directly into a wall. Norway had imposed significant trade restrictions in the 1880s. Tariffs made exporting to the rest of Europe expensive. The economics of shipping from a single Norwegian factory were increasingly unfavourable. Hans Mustad's solution was to stop exporting and start building. In 1886, Mustad opened a nail factory in Finland. It was the company's first facility outside Norway. Instead of shipping Norwegian-made products into a foreign market and paying tariffs, Mustad manufactured inside that market and avoided the tariff entirely. The model worked. Hans moved faster. In 1891, a horseshoe nail factory opened in Duclair, France. In 1898, another followed in Dalsland, Sweden. Each facility was prefabricated in Norway and shipped to the destination in components, then assembled on site. Mustad brought its own machinery, its own production methods, and its own trained workers. The factory in France operated identically to the factory in Gjøvik, across a continent by 1913. The expansion continued through the 1890s and into the early 1900s. Mustad's fishhook sales force travelled to every continent. Representatives carried samples to fishing communities across Asia, Africa, South America, and the Pacific. New markets opened almost every month. By 1913, the 5 major European powers were the United Kingdom, France, Germany, Austria-Hungary, and Russia. Italy and Spain were also large consumers of horseshoe nails. Mustad had established manufacturing operations in every one of those markets, with the single exception of Russia. By the mid-1920s, 8,000 people worked on Mustad production lines across 13 countries. The product portfolio covered more than 105,000 different hook types and sizes. By the 1950s, Mustad accounted for 50% of every fishhook produced on Earth. That market position had taken nearly a century to build. It would take less than a decade to nearly lose. Hans Mustad dies, 1918. On the 27th of February, 1918, Hans Mustad died in Oslo. He was 81 years old. Hans had run O. Mustad & Son for over 4 decades. He had taken a nail factory in rural Vardal and turned it into the largest industrial company in Norway. By the time of his death, the company employed 2,000 workers inside Norway alone and operated factories across multiple countries in Europe. Its fishhooks were being sold on every continent. Hans Mustad had not built a business. He had built an institution. Institutions do not die with their founders. What he left behind, the factory network. Mustad had constructed across Europe did not operate as a single centrally controlled organisation. It operated as a collection of independent units, each embedded in its own market. Each factory in each country ran its own production, managed its own workforce, and made its own operational decisions day to day. The factory in Duclair, France, ran like a French company. The factory in Finland ran like a Finnish company. They used Mustad machinery, Mustad methods, and Mustad quality standards, but they were not dependent on a headquarters in Gjøvik to function. They did not need approval from Norway to open in the morning. This structure had been built to solve a specific problem: tariffs. In the 1880s and 1890s, the most efficient way to get around a foreign country's import restrictions was to manufacture inside that country. Each factory was a local business in the eyes of local law. It paid local taxes, it hired local workers, it bought raw materials from local suppliers. The side effect of this design was resilience. A network of independent nodes is harder to destroy than a single centralized system. If one node fails, the others continue. Hans Mustad had built that network across 13 countries. He had not intended it as a survival mechanism, but that is what it would become. The 5 sons take over. Hans' 5 sons had been co-owners since 1905. They were Ole Mustad Jr., born in 1870, Hans Klarin Hovind Mustad, born in 1871, Halfdan Magnus Mustad, born in 1874, Wilhelm Martin Christie Mustad, born in 1877, and Nikolai Christian Mustad, born in 1878. When their father died in 1918, they inherited full control of O. Mustad and Son. This was the 4th generation of the Mustad family running the company. The first had been Hans Schickelstad, who built the original factory in 1832. The second had been Ole Hovelsen Mustad, who renamed it and expanded it. The third had been Hans Mustad, who industrialized it and drove it onto the world stage. The world the 5 sons inherited in 1918 had just come through 4 years of the First World War. Europe was rebuilding, trade was resuming, the company was intact, and the hook business had never been stronger. The peak of the 1920s, the years after Hans Mustad's death, were years of continued expansion. The factory network kept growing. New markets were opened, new hook models were developed, tested, and released. At certain points during this era, Mustad was adding new hook designs almost weekly as the sales force brought back information about what different fishing communities around the world needed. By the mid-1920s, the Mustad Group employed 8,000 people across 13 countries. Those 8,000 workers were running automated production lines, making horseshoe nails and fish hooks simultaneously. The product portfolio at this point covered more than 105,000 different hook types and sizes. To understand what 105,000 hook types means, a hook for catching a small freshwater trout in Norway requires different geometry than a hook for catching a tuna in the Pacific Ocean. Different species, different baits, different water depth, different line strength, different fishing technique. Every variable produces a different optimal hook design. Mustad had a hook for every combination a fisherman anywhere in the world might face. In many languages, the word Mustad had already stopped meaning a brand name. It had become the word for fish hook itself, what World War II meant for a European manufacturer. Then came the Second World War. The war began in September 1939. It would run for 6 years across Europe, North Africa, and the Pacific. For a manufacturing company with facilities spread across continental Europe, the war was not an abstract geopolitical event. It was a direct operational threat. Factories in occupied territories came under the control of occupying forces. Supply chains broke apart, workers were conscripted or displaced, export markets vanished. Mustad had factories in both Western Europe and Eastern Europe. The Western European facilities faced disruption but remained structurally intact through the war's end. The Eastern European facilities faced something different entirely, something that could not be reversed when the fighting stopped. The Iron Curtain wipes out 2/3 of the company. Germany surrendered in May 1945. Japan surrendered in September of that same year. The war was over. What followed reshaped Europe for the next 45 years. The Soviet Union extended its political and military control over Eastern Europe. Countries that had been independent before the war became Soviet satellite states one by one. The boundary between Western-controlled Europe and Soviet-controlled Europe became known as the Iron Curtain. On the Soviet side of that boundary, private property was nationalized. Nationalization meant the state took ownership of privately held assets, factories, equipment, land and buildings, without paying the owner. There was no negotiation. There was no compensation. There was no legal process through which a foreign company could contest the decision. The assets simply became property of the state. Mustad had factories on the wrong side of that boundary. The facilities Mustad operated in Romania, including factories in the cities of Galati, Timisoara, and a headquarters in Bucharest, were nationalized by the Romanian state in 1948. Every piece of machinery Mustad had shipped to Romania, every building Mustad had constructed, every production line Mustad had installed and trained workers to operate, were gone. Mustad received nothing in return. The human cost was equally severe. Approximately 8,000 Mustad employees, workers who had spent careers operating those factories, who had been trained on Mustad machines, who had built up institutional knowledge over years, were lost to the company. They were not laid off. Their factory simply had a new owner who was not Mustad. The Iron Curtain losses represented approximately 2/3 of the entire Mustad Group's operational capacity. In a few years, without a single decision Mustad could have made differently, 2/3 of what the company had spent 60 years building was gone. Why Mustad survived? The reason Mustad survived was the structure Hans Mustad had designed in the 1880s, a structure he had built to avoid tariffs, not to survive a geopolitical catastrophe. Each factory in the Mustad network had always operated independently. Independent management, independent accounts, independent supply relationships with local vendors. The factory in France had never relied on the factory in Romania to produce anything. The factory in Sweden had never received components from Bucharest. Every facility in the network was complete on its own. When the Romanian factories disappeared, the French factory had no operational gap to fill. Neither did the Swedish factory. Neither did the Norwegian facility in Gjøvik. Each of them simply continued running exactly as they had before, because they had always run exactly like that, on their own, with their own resources, under their own management. The loss was devastating in absolute terms. As a percentage of what remained, the surviving operations were structurally sound. They were profitable, they were embedded in their local markets, and they were ready to grow again. The decentralized structure that Hans Mustad had built to solve a 19th century tariff problem had, in 1945, kept his company alive through the most destructive conflict in European industrial history. Rebuilding and diversifying after the war. In the decades that followed, Mustad rebuilt, and it did not rebuild by simply replacing what it had lost. It expanded into new product categories, while the fish hook business kept growing in parallel. Paperclips were one major addition. At the peak of that operation, Mustad produced 70 million paperclips per year. The company also produced mattress springs, zippers, and screws, all manufactured using the same wire-bending technology that had driven the hook business since 1877. The principle was the same whether the output was a fish hook or a paperclip. Take steel wire, feed it into a machine, and shape it precisely. Margarine was different territory entirely. Mustad had been in the butter and margarine business for decades before the war. That operation continued for over 100 years in total, before the company finally discontinued it in 1996. The American market opened up in the 1950s. The United States in the post-war decades was experiencing rising incomes and expanding leisure time. Sport fishing was growing rapidly. American fishermen were buying more gear, more often, across more species and more geographic regions than any market in the world. Mustad opened its first American distribution center in the 1950s to meet that demand directly. By the 1950s, Mustad accounted for 50% of every fish hook produced anywhere on Earth. The latter half of the 20th century brought structural changes to the company itself. In 1970, O. Mustad & Son converted from a family partnership structure to a formal limited company. The company that Hans Schickelstad had operated as a single-owner enterprise in 1832 and that had passed through family hands for 138 years, became a corporate entity with limited liability. 7 years later, in 1977, the company split into two separate legal entities. One was named Mustad Industrier AS. The other was Mustad International Group BV. The two entities divided the business between domestic Norwegian operations and the broader international group. In 1997, Mustad Industrier AS divided again into Mustad AS, a second Mustad Industrier AS, and Mustad Eiendom AS. Mustad Eiendom AS was a dedicated real estate company to manage the land and property holdings the company had accumulated over 165 years of operation in the Gjøvik region. The Mustad family had controlled the company through 6 generations across 179 years. Hans Skikkelstad founded it in 1832. Ola Hovelsen Mustad renamed it. Hans Mustad industrialized it. Hans Mustad's 5 sons expanded it through the early 20th century. 2 more generations of the Mustad family carried it through the rest. At the end of 2011, the 6th generation sold the fishing company to NLI Utvikling, a Norwegian investment company with 1,300 employees and assets of 2.3 billion Norwegian kroner at the time of the purchase. NLI Utvikling later rebranded as ARD Group AS. For the first time in 179 years, O Mustad and Son was no longer controlled by a member of the Mustad family. The company did not stay with NLI Utvikling for long. In 2017, a majority of shares were sold to Verdane Capital, a Norwegian investment firm specializing in acquiring and scaling consumer and technology businesses. The 2017 sale was the second ownership change in 6 years. The company was now owned by its second consecutive private investment firm. The Mustad name remained, the factories remained, the 14,000 hook types remained. The brand that 6 generations and 179 years had built was intact. The people running it just no longer carried the name Mustad. Where Mustad stands today. Today, 1 in every 4 fish hooks produced anywhere in the world is made by Mustad. The brand operates in more than 160 countries. There are 195 countries on Earth. Mustad's products reach 82% of them. Its hooks cover every discipline of fishing: commercial longlining, freshwater sport fishing, saltwater big game, fly fishing, and everything between. That market position sounds dominant. It is, but it is also half of what Mustad once held, the shift from 50% to 25%. In the 1950s, Mustad made 50% of every fish hook on Earth. That number did not hold. Over the following 3 decades, the global fish hook market changed in a way Mustad had not faced before. Not a war, not a recession, not a trade restriction, but genuine competition from manufacturers who were building hooks that serious sport fishermen preferred. The threat came from Japan, the Japanese competitors. Japan has a fishing culture that runs deep. Commercial fishing and recreational fishing are both central to Japanese coastal life. Japanese manufacturers who entered the hook business in the latter half of the 20th century were not producing cheap imitations. They were engineering precision instruments. Gamakatsu was one of those manufacturers. It was founded in Japan in 1955. By the time it began exporting to Western markets in the 1970s, it had developed a needlepoint hook sharpening process that produced a hook tip sharper and more consistent than anything produced by standard manufacturing methods. Anglers who used Gamakatsu hooks noticed the difference immediately. Sharper hooks meant more fish landed on fewer strikes. Owner Hooks was another. Founded in Japan in 1972, Owner built a reputation among tournament bass fishing anglers in the United States during the 1980s and the 1990s. The brand became the standard hook in competitive fishing circles, where every hookup mattered financially. Hayabusa entered the market with a similar profile: Japanese precision manufacturing, a narrow target market, premium pricing, and exceptionally strong word of mouth among serious anglers. These companies did not try to compete across all of Mustad's hook range. They targeted the high end of the sport fishing segment, the anglers who paid attention to equipment, compared products, and were willing to spend more for measurably better performance. They took market share. Mustad's 50% became 25% over roughly 3 decades. What 25% still means? 25% of the global fish hook market is not a consolation prize. The global fishing hooks market was valued at approximately $354 million in 2022. No single competitor holds a larger share of that market than Mustad. Gamakatsu, Owner, and Hayabusa each hold smaller individual shares. Added together, the Japanese competitors represent a significant portion of the premium segment, but no single one of them produces 1 in 4 of all hooks made globally. Mustad retained the commercial fishing sector, the mid-range sport fishing segment, and the vast markets across developing regions in Africa, Southeast Asia, and South America, where fishing is still a primary food source and price point matters more than premium performance. 1 in 4 hooks, every day, across 160 countries. Continuous innovation, 14,000 types and counting. The competitive pressure from Japanese manufacturers in the 1970s and the 1980s forced Mustad to respond. The company invested in precision, sharpening technology, metallurgical research, and a continuous product development pipeline. According to Mustad's published materials, the company's current hook range covers 14,000 distinct types. That number reflects a development process running without interruption since 1877. Every year, new hook types are added as the sales force identifies gaps, fishing methods, target species, or geographic markets where no existing hook performs optimally. One example of recent development is a hook with its entire shank and gape built in a triangular cross-section profile. Traditional fish hooks are made from wire circular in cross-section, the same profile the wire has when it leaves the spool. The triangular profile has 3 flat faces along its length, rather than 1 curved surface. This changes how the hook penetrates and holds. It is a structural innovation applied to an object that has existed in essentially the same form for thousands of years. According to Hook and Net magazine's 2019 industry reporting, Mustad's current output is approximately 4 million hooks per day and 1.2 billion hooks produced annually. The Autoline system solving a different problem. Beyond sport fishing hooks, Mustad developed a separate product line for the commercial fishing industry. A commercial longliner is a fishing vessel that deploys a main line stretching across kilometers of open water with thousands of baited hooks attached at intervals. Before automation, deploying that line, retrieving it, and rebaiting the hooks required crews to work physically intensive shifts by hand. The process was slow, inconsistent, and costly in labor hours. Mustad developed the Autoline system to mechanize all 3 operations. The system deploys the mainline automatically, retrieves it after the soak period, and rebaits the hooks between deployments. Workers who previously spent entire shifts feeding hooks and bait into the water were replaced by machinery that performed the same work faster and more consistently. The result was measurable productivity gains in catch per trip, crew time saved, and fuel cost reduced, enough that the Autoline system became standard equipment on commercial longline vessels across multiple fishing nations. Building a multi-brand company. Under Verdane Capital's ownership from 2017, Mustad moved its strategy beyond being a single-brand hook manufacturer. The stated goal from CEO Kenny Reisa was to become a multi-brand powerhouse in the fishing tackle industry. A multi-brand strategy means owning several brands that each served different segments of the same market, rather than trying to force one brand across every segment. The Live Target acquisition was the first major move. Live Target is a Canadian fishing lure company. A lure is an artificial bait, an object designed to mimic the appearance and movement of prey that a target fish hunts. Live Target built its reputation on hyper-realistic lure designs that used actual photography of bait fish as the basis for each lure's colouring and texture. The brand had won awards and developed a following among bass and walleye anglers across North America. Acquiring Live Target gave Mustad a presence in the artificial lure segment, adjacent to hooks, but distinct. A fisherman who buys a Live Target lure still needs hooks. Mustad now supplied both. The manufacturing footprint today. Mustad's production network today spans 5 countries. Manufacturing facilities operate in Norway, China, Singapore, Portugal, and Malaysia. Sales offices have been established in Miami, in Singapore, and in Wuxi, China. The facilities in China, Singapore, and Malaysia reflect the economics of global manufacturing in the 21st century. Labour costs in high-income countries make it necessary to move certain production categories to lower-cost regions. Every major global manufacturer operates this way. The corporate headquarters remain in Gjøvik, Norway, the same municipality where Hans Schickelstad built the original factory along the banks of the Hundselva River in 1832. The name of the town is different. The factory buildings are different. The products are different. The headquarters have not moved in 193 years. Resolution. A farmer named Hans Schickelstad built a nail factory in Vardal, Norway in 1832. He built it to make wire and nails for a country that had no reliable way to produce either. His son-in-law took it over. His son-in-law's son industrialized it, expanded it across 13 countries, survived a financial collapse in 1879, and turned a machine kept secret for decades into a global manufacturing advantage. That man's 5 sons inherited it in 1918 and grew it to 8,000 employees across a continent. 2 world wars passed through the company. The Iron Curtain took 2/3 of it, but it rebuilt. 6 generations of one family ran it for 179 years. Then they sold it. Today, the company they built makes 1 in every 4 fish hooks cast anywhere on Earth, across 160 countries, from factories in 5, through a product range of 14,000 types that has been expanding without interruption since 1877. If you found this story worth your time, a like and a subscription help this channel keep making them. In June 2024, King Charles III granted Hardy a royal warrant. Only 145 companies in the world received one. The reel Hardy supplied him is over 130 years old. Its design has not changed since 1891. In 1872, William Hardy opened a gunsmith shop in Alnwick, Northumberland. He sold guns. 2 years later, he started selling fishing tackle. That small shop became the most decorated fishing tackle company in British royal history. How? The town nobody expected. In 1872, Alnwick was a market town of a few thousand people in Northumberland, England. It's at 34 miles north of Newcastle and 32 miles south of the Scottish border. There was no major industry, no financial centre, no reason for a global brand to start there. That year, William Hardy opened a gunsmith shop on Pakes Street. He sold guns and cutlery. His brother, John James, joined him the following year. Together they advertised themselves as gunsmiths, whitesmiths, and cutlers. The guns they sold were not even made in Alnwick, they came from Birmingham. A shift in direction. In 1874, an advert appeared in the Alnwick Mercury. Hardy brothers announced they were now selling fishing tackle. Both William and John James were passionate fishermen. That passion pulled the business in a new direction, and it never went back. At first, they sold tackle made by other companies. Their reels came from a supplier called Mallock. Their rods came from outside manufacturers. Hardy was a middleman. But the brothers were building a reputation for quality, and a reputation for quality is only as strong as the products behind it. By the mid-1880s, Hardy could no longer afford to put their name on someone else's work. The problem with buying from others fly fishing in Victorian England was growing fast. The upper and middle classes were flooding the rivers of Scotland and northern England, the Dee, the Spey and the Test. Demand for quality tackle was rising, and every serious angler knew the difference between well-made equipment and poor equipment. A bad reel on a fast-running salmon could cost the fish. A weak rod joint could cost the day. Hardy needed to make their own products, so they did. The first signs of greatness. In 1882, Hardy introduced their own split-cane fishing rods. The following year, they entered the International Fisheries Exhibition of 1883 in London. They won a gold medal. Hardy was no longer buying and reselling. They were building and winning. By the late 1880s, a third Hardy brother had joined the firm. His name was Foster Hardy. William and John James had built the business. Foster was about to build the product that would define it for the next 130 years. What a fishing reel actually does, before Foster Hardy picked up a wrench, it helps to understand what a fishing reel is and why it matters. A fishing reel is a mechanical device attached to a fishing rod. It holds the line, the long thin cord that connects the rod to the hook in the water. When a fish takes the bait and runs, the line feeds out from the reel. When the angler wants to pull the fish in, the reel winds the line back up. That is the basic job, but doing it well is harder than it sounds. When a large fish runs, for example a salmon, it can run fast and hard. The line has to feed out smoothly, without jamming. If the reel locks up, the line snaps. The fish is gone. If the drag, the resistance mechanism that controls how easily line feeds out, is set too tight, the line snaps under the force of the fish. If it is set too loose, the fish runs so far it cannot be recovered. A reel is a piece of precision equipment. It has to handle sudden violent force while staying smooth, controllable, and reliable. In the 1880s, most reels failed at this. The problem with every reel before 1888. In the 1880s, fishing reels were simple. They were built around a spindle, a central rod, and the spool rotated around it using basic friction. There were no ball bearings. There was no sophisticated drag system. The spool pressed against the frame and turned by friction alone. This created two serious problems. The first problem was friction inconsistency. As the reel wore down with use, the friction changed. A reel that performed reliably on day 1 might jam on day 10. Anglers had no way to predict when it would fail. The second problem was maintenance. To clean or repair the internals of most reels, an angler had to disassemble the entire mechanism. There was no clean way in. Every component had to come out, and getting it back together correctly required patience and skill that most anglers on a riverbank simply did not have. For casual fishing, these problems were an inconvenience. For serious salmon fishing on the fast rivers of Scotland, where a missed fish could represent an entire day's work, they were unacceptable. Foster Hardy understood exactly what needed to change. The third brother. Foster Hardy joined Hardy Brothers in the mid-1880s. William ran the finances. John James managed the people. Foster took over the reel department. He was an engineer at heart. He looked at the reels Hardy was buying from Mallock and saw a mechanism that had not fundamentally changed in decades. The friction drag system was the core of the problem. As long as the spool ran on friction alone, the reel would always be unreliable under pressure. Foster's solution was ball bearings. A ball bearing is a set of small, hard spheres arranged in a ring around a central spindle. Instead of the spool pressing directly against the frame and dragging by friction, the spool rides on the ball bearings. The balls roll, not grind. The result is a rotation that is dramatically smoother and far more consistent under load. The heavier the pull, the more the bearing system outperforms simple friction. The idea was not new in engineering. Ball bearings had been used in machinery for decades, but nobody had applied them to a fly fishing reel. Foster Hardy intended to be the first. 3 years of development. Foster filed his first patent on December 17, 1888. Patent number 18,373 described the basic workings of the new mechanism, a reel spindle supported by ball bearings, allowing the spool to rotate with far less friction than existing designs. But there was a problem. The early design placed the ball bearings around the outside of the reel frame. This kept them accessible, but it created a different nightmare. To disassemble the reel for cleaning or repair, every single ball bearing had to be removed individually through a small trap in the frame. On a cold riverbank, with wet hands removing dozens of tiny steel balls through a small hole, was a miserable and error-prone process. Foster knew it was not good enough. He went back to the workshop. For the next 2 years, he reworked the placements of the bearing race, the ring that holds the ball bearings in position. The solution he eventually settled on was elegant. Instead of placing the race on the outside of the frame, he moved it to the center, directly around the spindle. The bearings were now protected inside the reel body. The spool ran more smoothly than ever, and critically, the reel could be fully disassembled without removing the bearings one at a time. On January 13, 1891, Foster filed his second patent. Patent number 612 finalized the ball bearing system in its improved form. The design was ready. The launch. Hardy Brothers moved into their new purpose-built factory on Bondgate in Alnwick in 1891. It was a 4-story building with a wide arch entrance and a full shop front. For the first time, the company had the space and the machinery to manufacture at real scale. The timing was deliberate. Foster had spent 3 years developing the reel. The new factory gave Hardy the capacity to produce it in volume immediately. They were not going to build something revolutionary and sell it slowly. The reel appeared in Hardy's 1891 catalogue. They called it the Perfect. The name was a statement of intent. Hardy was not calling it the Improved or the Superior or the Advanced. They called it the Perfect, the ideal fly reel, the one that needed no further development. Whether that claim would hold up was a question the market would answer. The market answered immediately. By the end of 1891, within months of launch, Hardy Brothers were offering the Perfect in 13 different sizes. The smallest measured 2¼ inches in diameter, designed for light trout fishing with thin lines. The largest measured 5¼ inches, built for heavy salmon fishing on fast rivers. 13 sizes in the first year alone told the story. Demand was outpacing supply, and Hardy was racing to meet it. What made it different? The Perfect had 3 defining features that no competitor could match simultaneously. The first was the ball-bearing spindle. The spool rotated on Foster's patented bearing race, producing a smoothness that anglers had simply never felt before in a fly reel. Under pressure from a running fish, the spool released line evenly, without grinding, without sticking, without the sudden jerks that snapped lines on friction drag reels. The second was the click-check drag system. A small spring-loaded pawl, a tiny hinged arm, pressed against a toothed wheel on the spool. As the spool turned, the pawl clicked across the teeth, producing the distinctive ticking sound that became the reel's signature. The drag could be adjusted by the angler to control how much resistance the fish felt when it ran. Set it right, and a salmon could be played out with precision. The third was the full cage frame. The spool sat inside a complete enclosure rather than an open frame. This protected the line from tangling around the reel body during a fast run, a common and maddening problem with open-frame reels of the period. These three features working together produced something Victorian anglers had never held before: a reel that felt completely in control. Constant refinement. The perfect of 1891 was not identical to the perfect of 1905 or 1912 or 1950. Foster Hardy kept working. The original models were made entirely of brass, a dense, heavy metal that was easy to machine precisely but added weight to the reel. By 1895, Foster had switched to aluminium spools. Aluminium is significantly lighter than brass, while retaining strength. A lighter spool responds faster when a fish runs, and is easier for an angler to control through a long day on the river. By 1910, brass was almost entirely phased out of the Perfect's construction. Also, in 1895, Hardy expanded the Perfect range to include trout-specific models. These were narrower versions of the reel, designed to hold lighter lines for trout fishing rather than the heavier lines needed for salmon. Hardy called them contracted Perfects. They became the most popular models in the entire range and remained in production until 1995, 100 years after they were first introduced. In 1903, Hardy added a circular line guard to the full cage design. The line guard was a metal ring around the face of the reel that prevented line from springing off the spool and wrapping around the reel body during a fast run. It was a small addition. It solved a persistent problem. Foster Hardy continued refining every component of the Perfect for years. The drag mechanism alone went through multiple redesigns. Between 1908 and 1910, Hardy briefly produced a silent check version of the Perfect, a model with a modified pole system that eliminated the clicking sound entirely. It was in production for less than 2 years. Anglers hated the silence. They wanted the click. Hardy discontinued the silent check and went back to the noise. The expansion. In 1897, Hardy opened a shop at 61 Pall Mall in London. Pall Mall is a street in the St James's area of central London. In the late Victorian era, it was one of the most prestigious addresses in the country, lined with gentlemen's clubs, high-end retailers, and the kind of establishments that catered to wealthy professionals and aristocrats. Opening on Pall Mall was Hardy's signal to the market. This was not a provincial fishing tackle shop trying its luck in the capital. This was a company that belonged at that address. Foster Hardy moved to London to manage the shop personally. He stayed for over 20 years, finally leaving in early 1920. By 1900, just 3 years after the London opening, Hardy had warehouses in Edinburgh and Manchester, in addition to the Alnwick factory and the Pall Mall shop. Export orders were growing. The company began appointing agents abroad. By the late 1920s, Hardy had a network of agents that stretched from Brussels to China to Australia. The Perfect reel was in every window, every catalogue, and every agent's case across that entire network. One letter, sent by an unknown admirer sometime in this period, eventually arrived at the Alnwick factory, having been addressed simply to Hardy's, care of the King, England. The postal service delivered it without difficulty. That was the level of recognition Hardy had reached, a name so well known that the British postal system could route mail to them from a continent away with nothing more than the company name and a royal reference. The King himself would soon make that connection official. What a royal warrant actually is, most people have seen the phrase on a tin of biscuits or a bottle of whiskey, a small coat of arms and the words, "By appointment to His Majesty the King." But very few people understand what it actually means to receive one, or how difficult it is to earn. A royal warrant of appointment is a formal document issued by the British royal household. It authorises a supplier to display the royal coat of arms on their products and advertising, and to publicly state that they supply goods or services to the King, the Queen, or the Prince of Wales. It is not a prize. It is not an award. It is a declaration of a working commercial relationship. The royal household pays for everything it receives from warrant holders. the supplier charges full commercial rates. There are no gifts, no special arrangements, no honorary supplies. A royal warrant simply means that a member of the royal family has chosen to spend their own money on your product consistently over a long period of time and has decided that relationship is worth making public. To even apply for a warrant, a company must have supplied the royal household with goods or services for at least 5 years out of the previous 7. 5 years of consistent paid supply before an application can even be submitted. Then the application is reviewed. Most are rejected. The ones that are approved are signed personally by the grantor, the King, the Queen, or the Prince of Wales, making the recognition genuinely personal. At the time of writing, roughly 800 companies hold a royal warrant. Out of millions of businesses operating in the United Kingdom, 800 have met the standard. Hardy has held 8 of them across its history, 4 of which specifically recognised the company's supply of fishing tackle to the royal family. That number did not happen by accident. The first connection, 1898. Hardy's first royal connection came in 1898. That year, the Duke of York granted his personal patronage to the company. A patronage is not a full royal warrant. It is a formal expression of support and association, short of the complete authorization that a warrant provides. But it was the start of something. The Duke of York was a member of the royal family. He was fishing with Hardy tackle, and he thought enough of the company to say so publicly. 3 years later, in 1901, the Prince of Wales went further. He granted Hardy brothers a full royal warrant. This was the formal authorization, the coat of arms, the words by appointment, the complete recognition. Hardy could now display the Prince of Wales's royal arms on their products and tell every angler in Britain and abroad that the heir to the throne chose their tackle above all others. The warrants kept coming. In 1906, the Princess Royal granted her patronage to Hardy. In 1911, King George V granted a full royal warrant. That same year, Queen Mary granted one too. In 1923, Princess Mary added hers. In 1931, the Prince of Wales granted another. 7 connections with the royal family in 33 years, from 1898 to 1931. Every single one of them was earned through the same mechanism. A member of the royal family chose to fish with Hardy tackle, paid for it with their own money, kept coming back, and eventually decided to make that preference official. King George V and the annual visit. King George V deserves particular attention. He was not a passive warrant holder. He was an active customer. Every year, at the beginning of the year, Foster Hardy was invited to Buckingham Palace. He brought with him the latest range of Hardy tackle, new rods, new reels, new lines, and presented them to the King personally. King George V reviewed each item. He asked questions. He made selections. It was a private showing, conducted at the King of England's invitation, inside the palace, with the company's own representative standing in the room. This was not a ceremonial gesture. This was a man who took his fishing seriously enough to schedule a dedicated annual review of new tackle. The depth of that relationship produced one of the most extraordinary stories in Hardy's history. One year, the King's secretary reminded him that Thomas Hardy's birthday was approaching and that a congratulatory telegram should be sent. Thomas Hardy was one of England's most celebrated novelists, the author of Far from the Madding Crowd and Tess of the d'Urbervilles. King George V sat down and sent the birthday telegram. He sent it to the Fishing Tackle Company in Alnwick. The telegram arrived at Hardy Brothers, addressed as though the novelist and the reel maker were the same entity. Hardy Brothers kept it. It was, in its own way, proof of just how deeply the company had embedded itself in the King's mind. Hardy keeps innovating. While the perfect dominated the fly fishing world, Hardy was not standing still elsewhere. In 1932, Hardy patented the full bay alarm. A bay alarm is the curved metal wire on a spinning reel that catches the line and guides it back onto the spool when the angler winds the handle. Before the bay alarm, anglers had to manually pick up the line with their finger and guide it onto the spool after each cast. It was slow, fiddly, and prone to error. Hardy's Ultex spinning reel was the first reel in the world to feature a complete automatic bay alarm. When the angler turned the handle, the bay alarm rotated automatically and picked up the line. The cast and retrieve cycle became smooth and continuous. That bay alarm design, patented by Hardy in 1932, is now the standard mechanism on virtually every spinning reel produced anywhere in the world. Billions of anglers have used it. Most have no idea where it came from. Hardy was also winning on the competitive casting circuit. John James Hardy and L.R. Hardy travelled to the Chicago Fly and Bait casting tournament and finished first and second in one of the classes. The family's competitive credentials went further than that. James L. Hardy, grandson of the founder William, eventually held 25 British national professional casting records, 10 British all-comers professional records, and won the World Professional Champion Caster title 3 times. Hardy was not just making equipment, they were demonstrating, at the highest level, that their equipment worked. The Prince of Wales becomes a regular. The royal connection that would prove most significant for the modern era began in 1980. That year, Hardy was granted a royal warrant by the Prince of Wales. The Prince of Wales at that time was Charles, the eldest son of Queen Elizabeth II, and the man who would eventually become King Charles III. Charles had been fishing since childhood. His parents taught him. He fished in Canada, New Zealand, the Mediterranean, and the Caribbean over the course of his life. But his preferred water was always in Scotland, specifically the River Dee on the Balmoral estate, the royal family's private Scottish residence, where the salmon fishing is among the finest in Britain. Charles fished with Hardy tackle. He used a Hardy Y-rod, a salmon rod designed for the kind of double-handed casting required on wide Scottish rivers. His fishing companions on the Dee used Hardy Shearwater Neo-cane salmon rods, Hardy LRH 15-foot cane rods, and a range of other Hardy models. The reels throughout were perfects. The same reel Foster Hardy had designed in a Northumberland workshop nearly a century earlier was still the one the heir to the British throne chose to carry to the river. Charles later taught his own sons to fish on the same water. Prince William learned on the Dee. Prince Harry learned on the Dee. The Hardy warrant, held since 1980, ran through 3 generations of the same family fishing the same river with the same tackle. The 8th warrant, 2024. On June 5, 2024, King Charles III, formerly the Prince of Wales, who had held Hardy's warrant since 1980, granted Hardy its 8th royal warrant. This was the first round of royal warrants issued by Charles III as King rather than as Prince of Wales. Only 145 companies received one. Out of every business operating in the United Kingdom and beyond, 145 met the standard Charles III set for the first warrants of his reign. Hardy was among them. The 2024 warrant was the 4th specifically recognising Hardy's supply of fishing tackle to the royal family, separate from the 4 earlier warrants granted for other categories of goods and services. 4 warrants across more than a century, each one earned through the same mechanism. A member of the royal family chose Hardy tackle, paid for it, kept coming back, and decided to make it official. John Henderson, commercial director for Hardy, responded to the announcement directly. He said, "We are deeply honoured to receive this royal warrant from His Majesty the King. It is a testament to our ongoing commitment to providing anglers with the finest quality fly fishing tackle, and we are proud to uphold the standards set forth by the royal family." 8 warrants, 126 years. From the Duke of York's patronage in 1898 to King Charles III's formal recognition in 2024, the same company, the same factory in Alnwick, the same reel that Foster Hardy first filed a patent for on December 17, 1888. The tackle manufacturer that King George V confused with his favourite novelist. The company that a letter reached, addressed only to Hardy's, care of the King, England. The reel that Edward VIII fished with. The reel that Charles III still fishes with today. That is what 8 royal warrants looks like when you trace them back to where they started. The renaming, 1985. In 1985, the Harris and Sheldon Group renamed the company the House of Hardy Limited. The word brothers was gone. The original partnership between William and John James, the two men who had placed that advert in the Alnwick Mercury in 1874, was no longer reflected in the company's legal name. The House of Hardy was a grander title, but it was a corporate title. It belonged to a conglomerate, not a family. Further change followed. In 2004, the company merged with a fishing tackle business founded by a former Hardy employee. The combined entity was renamed Hardy and Grays Limited. Grays was a respected British fishing tackle brand in its own right. The merger gave the enlarged company a broader product range and a stronger position in the carp and coarse fishing markets, which Hardy had largely stepped back from since the Second World War. Hardy and Grays Limited continued to hold the royal warrant. It continued to manufacture the Perfect in Alnwick. The corporate structure around the reel kept changing. The reel itself did not. The American acquisition, 2013. On July 2, 2013, Hardy and Grays Limited was acquired by Pure Fishing, Incorporated. Pure Fishing is an American company. It is headquartered in Columbia, South Carolina. At the time of the acquisition, Pure Fishing was already one of the largest fishing tackle businesses in the world, with a portfolio of brands that included Abu Garcia, Berkeley, Fenwick, Penn, Shakespeare, and Ugly Stick. Hardy and Grays represented Pure Fishing's entry into the premium fly fishing market. The brands that Pure Fishing already owned dominated mid-range and mass-market fishing tackle. Hardy was different. It was a premium brand with a 139-year history, 8 royal warrants, and a reel that sold for significantly more than anything else in Pure Fishing's existing catalogue. The acquisition price was not disclosed. What was disclosed was the intent. Pure Fishing stated it planned to use its global distribution network to expand Hardy's reach into markets the brand had never fully penetrated. For Hardy, the acquisition meant American ownership for the first time in the company's history. A brand born in a small market town in Northumberland, built on a reel designed in 1888, was now part of a South Carolina-based multinational. The private equity era, 2018. 5 years later, in 2018, Pure Fishing itself was sold. Newell Brands, the American consumer goods conglomerate that owned Pure Fishing at the time, announced it was divesting the fishing division. The buyer was Sycamore Partners. Sycamore Partners is a private equity firm based in New York. The firm specializes in consumer and retail brands. The transaction completed in January 2019. The gross proceeds were approximately $1.3 billion. Hardy was now owned by a New York private equity firm as one brand inside a portfolio that also contained Abu Garcia, Berkeley, Penn, Fluger, Shakespeare, Spiderwire, and Ugly Stick, among others. The brand that King George V had reviewed annually at Buckingham Palace now sat in the same corporate structure as mass-market spinning lures and budget fishing line. This is the reality of what happens to heritage brands in the modern economy. Ownership changes, corporate structures change. The private equity model is built around acquiring, improving, and eventually selling. Hardy has been through multiple owners since 1967 and currently sits inside a portfolio managed by investors whose primary expertise is retail and consumer goods, not fishing. What has not changed is the factory in Alnwick, the people inside it, and the reel they are making. The collector's market. Away from the corporate changes, something else was happening with the perfect reel. Something nobody inside a boardroom in New York or South Carolina had engineered. Vintage Hardy Perfects were becoming some of the most sought-after objects in the entire world of sporting antiques. The Perfect was produced continuously, with occasional interruptions, from 1891 onward. Across that span, Foster Hardy and his successors introduced enough variations, different sizes, different check mechanisms, different frame designs, different materials, different markings that collectors eventually identified over 100 distinct model variants. Each variant has its own history, each has its own rarity, each commands its own price. The rarest variants became genuinely valuable. The 2¼ inch all-brass Perfect, the smallest size produced in the earliest years of manufacture when every part was made by hand, became the single most sought-after model. In 2014, one sold at angling auctions in London for £44,000. That figure is not an outlier in the Hardy collector's world, it is a data point. Early Perfects regularly achieve 4-figure sums at auction. The most exceptional examples achieve 5-figure sums, still made in Alnwick. In 2021, Hardy opened a new flagship retail space and museum on Bondgate Within in Alnwick, the same street where the original Bondgate factory had stood since 1891. The Hardy store and museum sits a short walk from where Foster Hardy built the first Perfect over 130 years ago. The museum displays the full arc of the company's history, from William Hardy's gunsmith tools to the commemorative reels made for royal weddings and coronation. August 17, 1962. The cover of Life magazine features Marilyn Monroe. The lead story is about her death. It is the magazine's biggest selling issue of all time. Buried inside is a 2-page article about a Finnish fisherman and a handmade lure. Orders for 3 million lures flood in. Normark, a small Minnesota distributor, can fill only a fraction. That lure was carved by one man, born in 1905, fishing a lake in Finland to feed his family. Today, Rapala VMC is the world's largest fishing lure company, and it is losing ground. Who was Lauri Rapala? Lauri Rapala was born in 1905 in Sisma, in what was then the Grand Duchy of Finland. His mother was a serving maid. His father was not in the picture. When Lauri was 7 years old, his mother Mari moved with him to the parish of Asikala, a small rural community about 116 kilometres from the capital, Helsinki. The clergyman at the parish ran into a problem. They could not remember the family surname, Saarinen, and so recorded it instead as Rapala, the name of the village in Sisma they had come from. The word Rapa in Finnish means mud. That clerical mistake became the name the entire fishing world would one day know. The world he was born into, Finland, in the early 1900s, was not an easy place to survive. The country had no major industrial economy. Rural families lived off the land and off the water. Fishing was not a hobby, it was how people ate. Europe's economy deteriorated further as the effects of the Great Depression in America arrived in Europe. Lauri worked as a lumberjack during the winter and as a farmer's hand or commercial fisherman in summer. There was no single career, there was only the next season. A life spent on the water. Lauri met Elma Leppänen when he was in his early 20s. They married in 1928 and lived in her parents' house in Riihilahti until 1933. The lake that defined his life was Lake Paijan. He fished its waters surrounded by evergreen forests and hundreds of interconnected lakes. Every morning, he rowed out alone. He trolled about 1,000 hooks on a trot line behind his traditional Finnish rowing boat, known in Finnish as a sutuven. He baited every hook himself. He had no motor. He rowed approximately 50 kilometers, 31 miles, every single day, except in storms. 3 trout weighing just 3.6 kilograms, 8 pounds total, earned the equivalent of 2 full weeks of pay at a nearby factory. The margins were razor thin. One bad season meant the family went hungry. That pressure is what pushed Lori Rapala toward an idea no fisherman had ever successfully acted on before. How fishermen caught fish before. 1936, for thousands of years, fishermen used one method: live bait, a real worm, a real minnow, a real frog on the end of a hook. The fish could smell it, feel it, and taste it. It worked. Artificial lures existed before Lori Rapala. Metal spoons had been used since the mid-1800s. A metal spoon is exactly what it sounds like: a curved, shiny piece of metal attached to a hook. When pulled through water, it spins and reflects light. Some fish strike it out of instinct. The metal spoon worked sometimes, for some fish in some conditions. But a spinning metal spoon does not look like a fish. It does not swim like a fish. It does not wobble like an injured fish struggling to stay upright. The gap was clear. No one had built an artificial lure that truly moved the way a wounded bait fish moved. No one had studied how predatory fish actually hunted, and then built something to match it exactly. Lori Rapala spent years staring at the answer from his rowing boat. What Lori saw on Lake Paijan. With so much time on the water, Rapala had much time to think, to observe, and to learn how the fish behaved, how the minnows swam, and how the injured minnows were more likely to be eaten by the larger fish. The observation was simple. When a large predator fish, a pike or a perch, attacked a school of minnows, it never chased the healthy ones. The healthy minnows were fast, coordinated, and moved together as a group. The predator ignored them. It went after the one that swam differently, the one that listed slightly to one side, the one that could not keep pace, the one with the off-center wobble that signaled to every predator in the water that this fish was weak, injured, and easy to catch. According to the recollection of his son Risto, our father really understood fishing. He recognized the relationship between bottom structure and where fish are located. He learned how fish fed and how they moved from one location to another, and Rapala understood the effects of weather on fishing. Rapala thought that an artificial lure could bring in more fish, and therefore more money, in addition to eliminating the time needed to bait hooks. He had identified the exact trigger that made a predator fish strike. Now he had to build something that produced it. Building the first lure, 1936. Lori had no workshop. He had no engineering tools. He had no budget for raw materials. He had a shoemaker's knife and whatever he could find around the house. After a lot of trial and error, and with the help of a hermit fisherman named Toivo Pilvalainen, who lived on an island of Lake Paijan, and Rapala's friend Akseli Soramaki, he created a lure with the right wobble to imitate an injured bait fish. Toivo Pilvalainen was a man who had spent his entire life alone on the lake. He understood fish behavior at a level most people never reach. His input helped Lori solve the hardest part of the problem, not what the lure looked like, but how it moved. The lure was carved from cork with a shoemaker's knife, covered with chocolate candy bar wrappers, and coated with melted photographic film negatives for a protective outer layer. Lori could not afford lacquer, the standard coating material, so he sourced melted photographic negatives as a substitute. The tin foil from chocolate wrappers gave the lure a silver sheen in the water. His first lure was created and designed for the purpose of catching pike. Pike are ambush predators. They sit still in shallow water and wait for something weak to swim past. They are exactly the kind of fish that strikes with a wounded minnow action without hesitation. When completed, Lori tied a string to his thumb and trolled it behind his boat. Pike and perch attacked it voraciously. His sons, who were young at the time, claim he would often bring in 270 kilograms, 600 pounds, of fish a day. Every day on a lake where 3 trout weighing 8 pounds total had previously represented 2 weeks of factory wages. The first commercial sale, 1938. Word spread quickly in a small Finnish village. Neighbours noticed Lori was coming home with more fish than anyone else on the lake. They wanted to know what he was using. In 1938, a local cooperative store in Kalkkinen started selling Rapala lures, marking the first commercial breakthrough for the company. Kalkkinen is a small village on the southern shore of Lake Pyjana. The cooperative store was the kind of general shop that rural Finnish communities depended on for basic goods. It was not a sports retailer, it was not a fishing tackle chain, it was a village shop that recognized the lures were catching fish and put them on the shelf. 2 years after Lorry carved the first lure by hand, it was a product for sale. He still had no factory, no employees, no business plan. Just a knife, some cork, and a technique no one else had figured out. First exports, 1955 and 1956. In 1955, the first Rapala lures were exported to Sweden. Norway followed in 1956. Sweden and Norway are Finland's closest neighbours. The fishing cultures of all three countries overlap significantly. Scandinavian anglers targeted the same species, pike, perch, trout, and fished the same type of cold, clear northern lakes. The Rapala lure worked there for the same reason it worked on Lake Pyjan. The fish behaved the same way. 2 countries in 2 years. The lure had crossed its first international borders before it had ever been seen in North America. The lure reaches the United States. Some of Rapala's lures made their way to the United States through the American Embassy in Helsinki, as well as the community of Finnish immigrants in America. Finnish immigration to North America had been significant in the early 20th century, particularly to the upper Midwest states of Minnesota and Michigan. Finnish immigrants brought their customs, their language, and in some cases, their fishing tackle. These lures caught the attention of Ron Weber, owner of a fishing tackle sales company called R.D. Weber Sales. Ron Weber was a Minneapolis-based sales representative. His entire professional life was built around fishing tackle. He knew what worked and what did not. He had seen thousands of lures. He had never seen anything that fished the way this one did. During a Canadian fishing trip in the summer of 1959, Weber's fishing partner pulled out an unfamiliar lure and tied it on his line. Suddenly, where there were no fish, there were fish galore. Weber came home from that trip with one objective: find out who made that lure and get a contract to sell it in the United States. Weber and his business partner Raymond Ostrom contacted the Rapala family through the Finnish Trade Council in Chicago, and a business partnership was established. Raymond Ostrom was the owner of Ostrom's Marine and Sporting Goods in Minneapolis. Together, Weber and Ostrom had the distribution network, the retail relationships, and the sales experience to bring a foreign lure into the American market. When Lorry received Weber's original letter, he had to have the foreign language text translated by a school teacher at the village school in Kalkkinen. The man who built the world's most effective fishing lure had never received a business letter in English before. He needed a school teacher to read it to him. Normark is founded. Weber and Ostrom's company was initially called the Rapala Company. It eventually changed its name to Normark. They placed their first order for 1,000 Rapalas in September 1959. 1 year later, they ordered 2,400. Between 1960 and 1961, that number grew to 31,135 lures. 1,000, then 2,400, then 31,135. In 2 years, demand multiplied by a factor of 31. And that was before a single magazine had printed a word about it. What Lorry left behind. When Lorry Rapala died in 1974, he left behind a business that had already outgrown him. The factories in Varksi and Rihilahti were running. Normark was distributing lures across North America. Orders were coming in from countries Lorry had never visited. The operation had long since moved beyond one man with a shoemaker's knife and a tank of water. But it was still, at its core, a family business. Lorry had never hired outside executives. He had never taken investment from a bank. Every person involved in making and selling the lure was either a family member or a trusted local. That structure had worked for 38 years. Now it had to work without him. After the passing of Lauri Rapala, the company was passed on to his sons, Risto, Esko and Ensio, who had all been involved in the company's business for a long time. It was during this time that Rapala was reformed into a limited company, Rapala Oy, a formal limited company structure registered under Finnish law. It was the first time the business had a legal corporate identity separate from the Rapala family name. The sons had grown up making lures by hand in a shed. Now they were running a company, the Shadrap 1982. In 1982, the company released the Shadrap, which led to an immense rise in demand. The Shadrap still remains one of the company's best-selling lures. The Shadrap was a different kind of lure from the original floater, where the original floater was designed to mimic an injured minnow swimming near the surface. The Shadrap was a crankbait, a lure designed to dive below the surface when retrieved, running at depth where larger predator fish hold position. It was shaped like a shad, a common bait fish found in North American rivers and lakes. American bass anglers, in particular, responded immediately. Bass fishing in the United States was not just a pastime in 1982. It was a competitive sport with professional tournaments, television coverage, and millions of recreational participants. When a lure proved itself in bass fishing, the entire American market paid attention. The Shadrap proved itself fast. It demonstrated something important. The company could build new products that worked. The original floater was Lauri's invention. The Shadrap was the son's proof that Rapala could innovate beyond its founder. Building the distribution infrastructure, early 1990s. Through the 1980s, Rapala continued to grow, but its distribution was fragmented. In North America, Normark handled everything. In Scandinavia, separate distribution arrangements had been in place since the 1955 Sweden export, but the company did not own its own distribution network, and it relied on partners. That changed in the early 1990s. In the beginning of the 1990s, Rapala acquired the distribution company Normark Scandinavia, marking a major expansion for the company. Normark Scandinavia was the distribution arm responsible for getting Rapala lures into the hands of retailers across Sweden, Norway, Denmark, and Finland. By acquiring it, Rapala stopped paying a middleman and started controlling the relationship with retailers directly. The margin that had previously gone to a distributor now stayed inside the company. This was the first major acquisition in Rapala's history. It was a signal that the sons were thinking about the business differently from how Lauri had. Lauri built a product. His sons were building a system. The family sells, 1995. The system kept growing, and growing companies eventually reach a point where family capital is no longer enough to fund the next stage. In 1995, the Rapala family sold Rapala's stocks to a new company founded by 6 members of the Rapala family. The management of the Rapala company, Bankers Trust and its subsidiaries, and funds managed by CVC Capital Partners Europe. Bankers Trust was a major American financial institution. CVC Capital Partners was a European private equity firm. These were not fishing people. They were investors who looked at Rapala's revenue, its brand recognition in 140 countries, and its demonstrated ability to grow, and decided it was worth putting institutional money into. 6 members of the Rapala family remained involved in the new ownership structure. But for the first time since 1936, the people with the largest financial stake in the company were not from Lauri's family. By 1997, the family had sold its remaining stake entirely. The business Lauri built alone on Lake Paijan was now controlled by private equity, going public in 1998. 3 years after the family sold the business, the company went to the stock market. Management, together with some private equity investors, listed Rapala Normark on the Helsinki Stock Exchange in 1998. The Helsinki Stock Exchange is Finland's primary financial market. Listing on it meant that any investor, individual or institutional, Finnish or foreign, could now buy a piece of Rapala. The company's value would be calculated daily based on the share price. Its financial results would be disclosed publicly every quarter. Its strategy would be scrutinized by analysts. This was the furthest possible structural distance from a fisherman testing lures in a tank. A major restructuring followed. In a few years, Rapala sold both its boat and caravan business and acquired the Norway distribution companies in the USA, Canada, the UK, Sweden, Norway, Denmark, Holland and Finland, as well as the French company Ragot. The boat and caravan business was a legacy diversification from earlier decades, a side operation that had nothing to do with fishing tackle. Selling it meant the public company was focused entirely on fishing. Acquiring the Norway distribution companies in 8 countries meant Rapala now owned the entire supply chain from factory to retailer in its most important markets. Storm, VMC and the push toward dominance from 1999 to 2001. With institutional capital, a public listing and direct distribution in its key markets, Rapala moved quickly. In 1999, Rapala acquired Storm Manufacturing Company, the plastic lure manufacturer. This was the company's first major acquisition since the purchase of Norway Scandinavia in the early 1990s. Storm Manufacturing Company was based in the United States. It made plastic fishing lures, a different category from Rapala's balsa wood hard baits. Plastic lures were cheaper to produce, could be molded into a wider variety of shapes, and had a large share of the American freshwater fishing market. By acquiring Storm, Rapala immediately entered a product category it had never competed in before. 2 years later came the acquisition that changed the company's name permanently. In November 2000, Rapala was approached by the French hook manufacturer VMC. The negotiation ended in Rapala purchasing VMC. As a result, the parent company's name shifted to Rapala VMCOYJ. VMC was not a lure company. VMC made fish hooks. It was one of the largest hook manufacturers in the world, based in Morvillers, France. Fish hooks are the component that every single fishing lure depends on. Every Rapala lure that had ever been made had a hook attached to it. Acquiring the company that made those hooks was a vertical integration move. Rapala now controlled a critical input to its own manufacturing process. Rapala MCOYJ, the name that appears on the Helsinki Stock Exchange to this day. The 2005 expansion, going global. By 2005, Rapala VMC had a public listing, owned its distribution in its core markets, and had added lure and hook manufacturing to its portfolio. The next move was geographic scale. In 2005, Rapala acquired the lure manufacturer Lure Jensen in the USA, knife manufacturer Martini in Finland, and cross-country ski manufacturer Peltonen in Finland. Distribution companies were established in South Africa, Australia, Malaysia, China, Thailand, and Switzerland. Lure Jensen was an American lure brand that had been in operation since 1932. It gave Rapala VMC access to a new segment of the American market and an additional set of product designs. Martini was a Finnish knife manufacturer with a reputation for high-quality fishing and hunting knives, a natural adjacency to the fishing tackle business. Peltonen made cross-country skis, a product that shared nothing with fishing tackle, but gave Rapala VMC a foothold in Finland's winter sports market. 6 new distribution companies in 6 countries in a single year, from South Africa to Malaysia to Switzerland. The company lorry built to catch pike on a Finnish lake was now operating on 6 continents. In 2006, Rapala acquired fishing line supplier Tortue in France. Fishing line is what connects the angler to the lure. It is a consumable product, Anglers buy it repeatedly, not once. Adding fishing line to the portfolio meant Rapala VMC could now sell an angler everything they needed, from the rod tip to the hook, line, lure and hook. The peak and the warning signs. By 1991, Normark had sold more than 150 million Rapala brand lures in the United States alone. By the late 2000s, that number was climbing toward 300 million globally. Rapala's lures are sold in 140 countries. That is more countries than are members of NATO. A lure that started in a Finnish shed now reached places Lauri Rapala had never heard of. In 2016, Jorma Käslin, who had acted as Chief Executive Officer since 1998, left the position and was replaced by Jussi Ristimäki, the previous Executive Vice President of the company. Käslin had been Chief Executive Officer for 18 years. He had overseen the initial public offering, the Storm acquisition, the VMC merger, and the 2005 global expansion. His departure marked the end of the generation of leadership that had built the modern Rapala VMC. In 2020, Nicholas Cederström Warchalowski was appointed as the new President and Chief Executive Officer of Rapala VMC. 3 different Chief Executive Officers between 2016 and 2020. In a consumer brand business built on consistency and trust, leadership turnover at that pace is a structural warning sign. Louis d'Alençon was appointed President and Chief Executive Officer on November 16, 2022. 4 Chief Executive Officers in 6 years. Chinese fishing tackle manufacturers, searching for ways to utilize unused manufacturing capacity, began flooding domestic and export markets with low-cost alternatives. Rapala's market share in China and neighboring regions came under immediate pressure. The same competitive dynamic that had destroyed other Western consumer brands in other industries had arrived in the fishing tackle market. A company that had never faced serious competition at the price point was now facing it everywhere, simultaneously. The company that Lauri's sons had grown from a shed into a global conglomerate was about to face the hardest years in its history. What was happening to the fishing tackle market? To understand what happened to Rapala VMC after 2020, you need to understand what happened to the fishing tackle market overall. The COVID-19 pandemic arrived in 2020. Gyms closed, restaurants closed, travel stopped. Millions of people who had never fished before picked up a rod because it was one of the few outdoor activities still permitted. Fishing license sales in the United States jumped by 3.5 million new participants in 2020 alone, the largest single-year increase in recorded history. Rapala VMC's operating profit for the second half of 2020 reflected that surge immediately. For the period from July through December 2020, the company's operating profit increased to 17.3 million euros, compared to 5.8 million euros in the same period the previous year. That is a near tripling of profit in 6 months. Retailers could not keep Rapala lures on the shelves. The company scaled production to meet demand. Inventory built up across the supply chain. Then the pandemic ended, the crash after the boom. When COVID restrictions lifted in 2022 and 2023, people returned to the activities they had missed: travel, sport, concerts, gyms. Fishing participation declined from its pandemic peak. Retailers who had stocked up heavily during the boom were left with warehouses full of unsold fishing tackle. They stopped placing new orders and started selling down what they already had. This problem had a name. It was called the destocking cycle. It was not unique to Rapala. The entire outdoor recreation industry faced it after 2022. But Rapala felt it hard. The group's net sales for full year 2023 declined 19% year over year to 221.6 million euros compared to 274.4 million euros the year before. 52.8 million euros in revenue, gone in 12 months. That is not a dip. That is a structural reversal. Consumer spending remained tight due to high inflation, and this impacted higher ticket item sales. Sports fishing also competed with other recreational activities that had previously been restricted by COVID-era rules. Rapala's core products, high-quality balsa wood hard baits, priced at $10 to $25 each, are discretionary purchases. When household budgets tighten, a $15 fishing lure is one of the first things people stop buying. The sales decline came evenly from all product categories. The problem was not one weak product line dragging down the rest. Every category, lures, knives, line, accessories, declined together. The China problem. The destocking cycle was a short-term problem. It would resolve when retailers worked through their inventory and started ordering again. The competition problem was permanent. Chinese fishing tackle manufacturing had been growing for decades. China had the factories, the labor costs, and the raw material supply chains to produce fishing lures at a fraction of what it cost to make them in Finland or Estonia. For years, Chinese manufacturers had supplied the lower end of the market. Cheap lures sold under generic brand names in discount stores. They were not a serious threat to a premium brand like Rapala. That changed after 2020. China and neighbouring markets witnessed increased competition from local brands as Chinese fishing tackle manufacturers searched for ways to utilise unused manufacturing capacity. Chinese factories that had scaled up during the pandemic boom were left with the same overcapacity problem as Western retailers. Their solution was to move up the value chain, to produce better designed, better finished lures, and sell them under recognisable brand names at prices Rapala could not match. The competitive landscape evolved amid tariff tensions, with Asian manufacturers increasing their investment in domestic markets and emerging as stronger local competitors. A Rapala original floater, hand-tested and tank-certified, retails for roughly $10 to $15. A Chinese-made alternative lure, sold on the same platform by the same retailer, costs $1 to $3. For a casual weekend angler who fishes 6 times a year, the $2 lure is a reasonable choice. They do not need the precision that Rapala built its reputation on. Rapala's entire value proposition rested on quality. That argument weakens when the cheaper option catches fish. The numbers get worse before they get better. The year 2023 was difficult. The year 2024 confirmed that the difficulty was not temporary. Despite operational improvements, net profit fell to a €5 million loss in 2024, driven by currency derivatives and restructuring costs. A net loss on the books of the world's largest fishing lure company, a company that had sold 225 million lures by 1999, was now posting a loss. The scale of the decline from the company's peak years was stark. 4 CEOs in 6 years, a 19% revenue decline in a single year, a net loss in 2024. These are the conditions that force a company to either restructure or disappear. Rapala chose to restructure. The One More Turn strategy, 2023. In late 2023, Rapala launched a new strategic plan called Together, One More Turn, focused on improving profitability and working capital management. The name referred to inventory turns, a measure of how quickly a company sells through its stock. A company with slow inventory turns has cash tied up in warehouses. A company with fast inventory turns converts its products into revenue efficiently. Rapala had an inventory problem. The strategy was designed to fix it by cutting slow-moving products, streamlining the supply chain, and focusing investment on the brands and categories